Hello, hello. And we work on Kast again today, the programming language. Hello, Nigel. Hi. All right. I think that maybe today we take a break from the complex stuff and do something simple, which is the syntax and some of the syntax related things. You know, instead of fixing my inference, let's do something simple. So here, so yesterday we tried to do the rewriting thing where Bash Bunny joined the Discord server. Yeah, I did see that. There's just no action in the Discord though. maybe we should talk about something there sometimes, right? It just feels if I'm streaming every day, then am I supposed to talk about stuff off stream too, instead of taking a break from this stuff? I don't know. How do other Discords work usually? I'm not active in any other people's Discords either. Cast inference completion. Not inference completion. Inference completion is the thing that we did yesterday, and we figured out that not everything is inferred in the language. Most Discords are either dead or overrun by terrible memes. Yeah. So it's okay then, right? Basically the only thing that happens in my Discord is that I'm doing the stream notifications. If you don't get notified by Twitch, you can get notified by the Discord. Right. Okay. Cast. So what we did is we did the rewrite. In the formatter, we can do the rewriting now. So here's the functor source code, which changed the function application from no parentheses to requiring parentheses, right? This leads to some things. We have like double parentheses now, which maybe we need to figure out how to automatically remove unnecessary parentheses. When I'm writing the code in OCaml, so that the formatter here is already doing this automatically. So if I say let x be 2 plus 2 like this, and then I just save the file, it removes all of the unnecessary parentheses. So yeah. We can do something similar, I guess. Although parentheses, they do have like semantics. The parentheses are actually the things. This means you can now rewrite all your code in the CurveScript syntax. Yeah. So yeah, we might work on that, or to remove unnecessary runs on format. And another thing that it leads to, if I do this for all of the code, then it's not going to work, or rather, if we actually do change the syntax of the function call into requiring parentheses, then what's going to happen? Then what's going to happen is, how do we parse this thing? Just like call function f, right? How should this work? Because there is no child AST node here in this case, right? So previously we had a special syntax basically for the unit. So unit is the syntax which is open parentheses and ending and like closing parentheses. But I guess what we should do is that the unit should be the empty AST node. And so we would automatically treat this parenthesis just like any other parenthesis. Like this scope syntax definition is having some inner node inside of the parenthesis. But if this node, but this node cannot be empty, which is why we need this separate syntax rule currently. So I think what we want is to allow empty nodes in some places, but not in all of the places, right? I think only in those places which are surrounded by parentheses, where we reset the priority. So whenever we see :any, and :any is literally only used inside of parentheses currently. Right? One of the things that we cannot do because of this, for example, is we cannot create the AST of the empty code. Right? This cannot be parsed. We must, in order to create an AST, to have some code inside. Right? So when I compile the file, it means that the file does not necessarily contain an AST right now. But if we actually create the empty AST node, I think it will simplify things. Getting empty syntax node. AST node. Syntax node. It is called syntax node. Okay. Yeah, let's do that. So here's what we store as the AST currently. AST node is either a simple is a token with the comments attached to the token, the comments before the token, or it is an error node if we fail to parse something, or it is a syntax node which extends the syntax, or it is one of the nodes that is defined with our syntax rules, right? But now we will have a new variant here, which is going to be empty. Let's do that. Okay, print. Empty. Sure, let's just do this in both of these cases. Okay, yeah, so here's the parser. Now the parser needs to create the empty node at some point, but also over here is trying to extend incorrect priority. On the first iteration, need to check that start value satisfies previous filter, right? Priority, syntax rule priority option. What is the priority of the AST node? That's right. AST empty none. Okay. Is there anything else? Core syntax. So this is me quoting the thing. AST shape. So yeah, error or simple or empty are going to be put as is in the Kast compiler. Now when we're compiling, so if I want to compile an empty node, then we are going to match the kind because we are trying to compile an empty assignee, which is going to be assignee unit init assignee span state, right? If it is an expression, then we say expression. We don't have expression unit. We need to say expression constant value unit. Init expression span state. If it's a place expression, this is going to be hello penguin. A place expression just means that it's a temporary unit value. Place expression temporary expression. If it's a type expression, then it's going to be a type expression which returns a constant type, which is the unit type. Let's expression be this. Expression here. Temporary expression here. It should be type expression, expression. And if it's a pattern, then this is going to be a pattern unit. Make pattern span state. Okay, now this says this expression has type assignee. That's because this pattern match is not being inferred properly. This is a GADT, and GADTs lead to bad inference in a camel. So say let result, which is a compiled kind, is this in result, right? This expression is type a. No. We need to return a. Yeah, that's right. So we need to do explicit type annotation, otherwise it's being inferred incorrectly. All right, so this means that I can compile now the stuff with the empty nodes. LSP semantic tokens. If we have an empty AST, then we don't do anything here. There is no tokens in the empty syntax. Sequence empty. LSP selection range. Find spans. If it is empty, we return empty list. Okay. And this is the test Kast parser. We actually have tests. A little bit of the tests. matches AST and expected. Bum, 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 bum. Well, I guess if we say empty, then it doesn't match. But we do want sometimes to have empty, I guess. I'm not sure if I'm going to like keep this test working. Maybe I should try. Kast highlight. So if I am trying to print the empty, I'm not doing anything. The formatter. Now. The rewriting the empty just keeps it as is. No need to rewrite anything. And then the formatter. This is just print. So yeah, if I want to print the empty node, then we just don't do anything. There's nothing to print, it's empty. Okay. Let's see now. Echo hello world cast parse. Okay, so hello world is still being parsed. If we do call the function f like this, it is going to parse, right? What's not going to parse, I guess, is the quoted nothing. We cannot do that. I need to escape this, I guess. Right, so this does not work. Skipping unexpected this, right? So this over here should contain the empty child node, basically. Okay. So yeah, this is now we go into the parser. Now we go into the parser. So parse result is we either made progress and parsed an EST, or we made no progress. Bum 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 bum. Parse one state, parse rev this. Yeah. It's been a while since we opened the parser code. I guess this one, terminate. So what we construct is we construct like a state machine with all of the syntax rules in it, and then we traverse it, and we are trying to arrive at the terminal node in the state machine. If I did not make progress, though, we just return no progress, right? But maybe sometimes I want to still return that progress was made, but I have parsed an empty node. Is that the case? Otherwise we are still at the root node. Like, yeah, we are at the root node here if I did not make progress. Right. maybe not there, though. Maybe not in the termination. Maybe, like, termination should return the non-empty ones, always. Let's see. So here's the overall structure. In order to parse the AST, so parse value. Parse value. Parse value in the inner context. Parse or extend minimal. Context. What's in my context? Unused comments, rev, lexer, rule set, filter, syntax priority filter. This is the one. Yeah, this is the one. I guess. Whenever I try to parse a value, if I'm trying to parse the value and I can parse any value, then I can return the empty AST instead of the no AST that was parsed, which is different. Let's say let result be this in, right? So we say if context filter is any and result is none, then I will return some AST empty. Otherwise, we will just return the result, right? Yeah, it's not AST empty because I need to have the span. Yeah, so the question into it, what is the span of the empty AST node? If it doesn't have any tokens, then how do I know where it begins and where it ends? Well, in the current position, it's just like a single position in the source code, right? It is the position in the source code. So we have in the context, we have the lexer. And lexer can give me the position. Lexer read the position. This is maybe not correct because it maybe should be position of the picked token. Yeah, I think like this is what we need to keep to do this to do, and to return the position of the picked token if we have not consumed it. So we're going to match lexer picked with none, then it is the reader position, and if it is some token, then it is token span start, right? So now I can just get the lexer position here. Start is context lexer position. Finish is also lexer position. Beauty is context lexer. Lexer source. Yuri. I guess this. Alright, there you go. So this has been parsed. We now quote an empty AST node. I should probably try some Anything else? Let's make sure that everything is still parsable. Well, it seems like the standard library still works, still parsed, and the REPL still works, so I didn't break anything, which sounds good. Okay. Yeah. So this also means that now we can remove the rule from the syntax rules. The unit is no longer a required syntax rule, because the unit we just construct by having an empty syntax node. Now things will break, probably. Always break. What? Things will break? I don't know. I think they should not break. They did break. Okay. Type shape. Type is not unit. Let's take a look over here. Okay. It did break. Because it now thinks that this is a value unit, right? I think it's just like because I did not do the type correctly in my compiler. So when I'm compiling an empty node, which is a type expression, it returns the expression, and the expression returns a constant value unit. But I need to know the value unit, I need the type unit. So yeah, this is going to be different. We're going to still have a constant here. A constant with a value which is a type, and type is a unit. Is that how I do it? How I did previously? We have core unit over here. If it's a type expression, oh, we have a dedicated type expression unit apparently, which feels like is unnecessary, but okay. Yeah, we just do that. And this is going to work. Hello, Nerdzel. Yeah. So it parses the standard library, and I don't know. So this is just the empty AST node if we do it like this. Yeah. I'm going to assume that this works properly. But we are going to, I guess... Yeah, now I want to like rewrite the thing. The entire thing by having the... empty AST node. What about test? Yeah, my tests are still working. Good. Just commit this. Wait, you almost have 1 million points, really? That's a lot. Yeah, so now what we can do, by the way, is that our parser, let's take a look over here. Here's the parser. Now the parsed result is the AST, which is no longer optional. We already have an AST. We always have an AST, right? So whenever I parse value here, we can now always get this thing. It is no longer optional. We now have the AST, but an empty AST. If it's empty. Which is also going to simplify some things. Right? Okay. So now, for example, over here, I'm trying to compile, or I'm trying to import a file, right? And if the file has no source code, then we would create a unit. But now we just, you know, we just compile the AST. That's all that we do. That's all that we do. We compile parsed AST. That is all. There's also trailing content and the file, which is a position. Sure. Value. Okay, core syntax. Core syntax, this is what? This is me including another file, right? So now including another file also means that my parsed AST is no longer an option. Included file is empty. That was an error previously, but now we should be able to do that. AST is just parsed AST, that's all. And then we just compile the parsed AST. Okay. Kast compiler CLI. So when I compile, yeah, over here, if we compile none, then we just print none, and we don't do this anymore. There is no match that needs to happen. Right? It's just that the AST is parsed AST. Okay. Interpreter is the same. No need to match anything here. AST is just parsed AST. Same with the REPL, I guess. Nothing to do here. Parsed AST. Simple syntax. Parse. That should just be AST. AST, parsed result, parse. See, this is no longer option print, this is just AST print. And this should just return process AST. Highlighter also just needs to do this. Formatter, no need to option map anymore. We just say that we rewrite the parsed AST. Formatter here. This just print AST AST. Parser CLI also only has a single branch. Processing, option bind, parsed. Option map. Now Test the parser. This is no longer optional. Expected. No need to option get here anymore. This no need to match. It is always some. Selection range AST. AST. What is this? Semantic tokens. We just say AST collect. Collect AST. That's all that's needed. Some AST is none. Then this is just having the none, right? Yeah, this just means that if I have not successfully parsed the file, then we do this. Yeah, sure. Kast JavaScript. This is unnecessary. We don't match. We just say parsed AST. And we are compiled. Okay, nice. Kast. I think this should all work. I'm just going to commit this. Parsing now always returns AST. Empty instead of none. Okay. So yeah, we do like just echo nothing, cast parse. This was not working before, but now it is actually just empty. All right. We can try to go to this. Remove unnecessary parentheses on formatting. So we actually do change the syntax finally. So the way we remove unnecessary parentheses, normally the parentheses are only needed. The parentheses are used for two things right now, actually, which is why I was considering to have actually curly braces as a different way of doing the parentheses. So parentheses, they reset the priority. So they are used to group an expression, which would otherwise be bound differently because of priorities, right? And also it introduces a new scope. It also introduces a new scope. But yeah, what do we think about this? So it means that when I call a function like this, right? I call function print. And I can say like let x be 1 to 3, and then I print like to string x, for example, right? So this exists only in this scope. If you want to introduce a scope like that in Rust, you would do the parentheses, the curly braces. Is there any reason for me to distinguish between the two, though? Is there any real reason? Why would I want to maybe like have a let inside but not introduce a scope. It would introduce the scope in the outer scope then, right? Which means that I would be able to use the let after I call this function still. Why would you declare X inside the function call, by the way? I'm not aware of this. What languages are you familiar with? This is not, it's not inside of a function. It's me calling a function with X to string, right? And we just define it implicitly over here. If we were writing Rust, right? Let's say we have function f, which takes x, which is an integer. I don't think there is an alternative of that in Python, because it has to do with languages which treat everything as an expression, kind of, right? So you can call the function f with 1 to 3, but you can also call f with let x be 1 to 3 and then x, for example. Right? So this block is the block that is evaluated to the last value in the thing. So this x is a variable that is invisible to the outside scope. It is useful. Not exactly like this. Not exactly this example is useful, but in general, being able to scope your variables to the smallest scope that is actually needed for them is kind of nice. Yeah, in OCaml here, we also write some code like this, you know. Here's function main, and I want to call the function f using x, which is defined in this scope. So I just do, so in OCaml we also do just round parentheses, but we just do let x be 1 to 3 in. So I guess like the let in is what introduces the new scope with the new variable in OCaml. So basically what this means is that let's forget about the scopes though, right? If I did not have the scopes, and if this was just to group the expressions, then how do we know that the parentheses can be removed, right? If we say like 2 plus 2 plus 2 plus 2, right? So this is already being parsed as, you know, because this is left associative operation, this is already parsed as this. So these parentheses are unnecessary, right? Which means what? The parentheses are unnecessary if the priority of the rule used inside here could be used directly here, right? Is satisfying the filter for this value. We already have all of the things. It is actually really simple logic, but sometimes we can actually not remove the parentheses in case we introduce the new variable inside because of the scope semantics. Yeah, Kotlin also is like, I don't know, I feel like it is just such a good feature. It should be present in every language. Everything is an expression, is such a nice thing. Like, why should things, like, the less amount of special things there is, the better, right? It makes the language simpler also. Everything can be written everywhere. You can write a function inside of a function instead of only having top-level functions. That's also a nice thing, right? Like, why should there be like some extra rules? I want to be able to write everything everywhere. So does this code contain the introduce the scope? That is a question, right? Right now we always do this. So we cannot necessarily remove the thing. Figuring out if I am introducing any variables over there, maybe. But that is something that should not be the logic inside of the formatter. That would be weird. We can start by doing this simple. If we only do this, we only remove the parentheses like in the root. So we are going to preserve the parentheses in like the math expressions like this. Then, but we are not going to preserve the parentheses if they are already inside of the other parentheses. So like these parentheses are going to be removed, but not these ones. You know? Maybe that's good enough. For me, for now. Because maybe like sometimes I actually want to keep them for readability. Sometimes I do want that. Actually. So only redundant parentheses because they already exist. Only those we're going to remove. For now. Maybe this should be like an optional thing. But yeah. So let's just, yeah, I think like duplicate parentheses can be like just always removed by the formatter. Not even conditionally, just always. So when we format the AST, we need to now keep track into what is the filter that we had on the parent. And the filter is going to be any on the root. So we have the filter, which is going to be syntax rule part. No. Syntax rule filter. Syntax rule priority filter, yes. Rule priority filter. Any greater or equal, that's what we can have. Filter. Wait, print AST, this is the top level one, right? Print AST. Fine. Print AST. Oh, we have a parent. Hold on, we have a parent. Parent is a parent option. What's a parent? What is a parent? We have type parent. There you go. We have a rule. Yeah, we have the parent rule. But I guess this is like kind of the parent node. What we want is the it's not like exactly the parent then. Parent none, parent some, rule wrapped. I mean, it's only in one place, so yeah, sure. Let's have this here. Filter. So it's not like exactly parent. It's the filter of myself, not the filter of the parent. So what would I call this? The parent rule, parent wrapped, and the filter. Let's just have it as an extra argument. I don't think it's that big of an issue. Filter. So this over here depends. I'm just going to use the filter. How do I even parse this syntax? Thing value after. Parse value context. Oh, just using the original context. Yeah, sure. Hello, Giancaletito. How are you feeling? Good. You? Facing college? Nice. So yeah, if I have the syntax, then the filter is going to be the original syntax, the original filter, and if not, filter. So I don't have the filter here, right? Which makes sense. I need to print parts. Yeah, over here we have the value. Yeah, this over here. So in the rule, we have the binding, right? So let's call this binding. So I know the filter of the binding in the syntax rule priority. This is filter kind. This is filter kind and not a filter. Fine, let's give it a filter kind, you know, binding priority filter. Yeah, so filter should be the priority kind. Over here we have filter, which is any. Yeah, so this is now the filter kind. It automatically is inferred now. Okay. Yeah. So now that I have the filter as my option, now I know that if so, like, there is only a single thing that I want to remove, which is the parentheses. Put the professor in the weird spot where he couldn't give an answer. A generic function that printed out an array. What if the input is not an array? Spent 30 minutes figuring out how to make the function check C++ type. Yeah, you just don't do that in C++, right? In C++, you just assume that, like, you just don't call the function with a input that is not the array. That's not the C++ way. You blame the programmer if they use your API incorrectly. That's the way of C++. Wrapped. I basically want to see if this is the parentheses, then we are going to... what else do I have here? Well, nothing else, right? Yeah, then I have the children. Yeah. You can restrict the type in C++. When you're writing generic code, you can restrict your generic parameter. Well, through compile time magic, yeah, you can. Of course. Or is there like something that I don't know? C++, like using the C++ concepts, for example, right? But do people use this already? There is the thing that is called concepts, and requires yields pool that is right. Yeah, this is like one of the new things. I don't know how much people actually use it to describe that, or they just rely on the but both approaches suck. Yeah, well, I mean, they are better than like the old way before this was introduced, right? Where you just have like 1,000 lines of error messages if you use the wrong type. I'm assuming. I never used this actually. Like, is this just going to give you a shorter message where it means that this is not required and it's not even going to try to instantiate the template then, right? I hope that this is how this works. No, the message is still terrible? Yeah? It's just less long? I see, okay. I guess I just make a special case here. I'm just going to hardcode the parentheses. Parentheses like the only thing, right? So we say that if rule name is equal to core scope and filter is any, then we're going to do one thing, otherwise we're going to do all of these other things. What do you mean unbound constructor? It's literally in this type. There's any here. Syntax. Priority any. Or you make double patterns as syntax and then rewrite it also. This is not about the double patterns, or I mean, it's not about the double pattern, because if we have the parentheses to be part of like the function call, right? It means that these are repeated parentheses, but it is not a repeated pattern, right? So I would need to have a dedicated rules for like nesting a scope inside of a function call and like all of the kind of things, you know. So the general approach is because like outer parentheses means that we are resetting the priority filter to any. So this means that we are inside of the parentheses, any kind of parentheses, not necessarily just the scope parentheses, but it may be the ones that are part of the syntax of the function call. Does that make sense? Yeah. Hope Rust and others will succeed. C++ can be real painful. I think Rust has already succeeded, though. Rust is already officially included in the Linux kernel, and it's no longer in experimental state. Looking forward to Jai as well. Jai sounds, yeah, Jai is doing a lot of things that I'm doing too. But as far as I understand, Jai is not going for safety as one of the things. And yeah, we have different opinions with John below there. Although I heard people say that you can write your own borrow checker in Jai. I mean, maybe that's like, if you can implement some language feature inside of a language like that, that would be really cool. Yes. Can we have a language where we implement the borrow checker inside of the language? But like, even if you do that, then there's still a lot of code that is not using the borrow checker, right? Like and the borrow checker is like one of the things, right? There is a lot of things that are potentially still unchecked, I would assume, right? The effect system that I want to have in my language is another example. Pretty sure Jai does not have that. So like, Jai has the context system, the implicit context system. Can you define in Jai a context and then like and then like not and like call a function where this context is not present, basically? That's the question. What was Jai written for primarily? For the game development. John Blow is making a game with it. Tulane is a big win over Rust. You can add very detailed AST analysis. I mean, yeah, I understand that, and maybe we are also going to like look into that today in my language here, right? I do have AST-based macros, but we also can add the APIs to do type inspection, so we can generate code based on what the compiler already knows, right? As far as I understand, Jai allows you to do something similar. That's also what Zig allows you to do. It's just like Zig doesn't really have macros, but you do have the ways to inspect like the types and generate code based on that, basically. Which is similar. You probably create a fill C-esque system in Jai since you have everything, and it would be a lot easier than patching LVM. What is fill I mean, I already looked at that fill C, but oh, it's a memory safe implementation of this, but isn't it? So you are saying that this is not a separate language? No, this is a garbage this is the one with the garbage collector. Yeah. So this is one that adds safety to C++, but it is like 1,000 times smaller and something. It's a patch on an LLVM, but like there is some things that must like for doing proper borrow checking, like in Rust, you need changes to the source code. Not everything can be inferred, or at least you need to be able to add those things. You know, but yeah, I do like the idea of having a compiler or a language which is basically made as a set of plugins, I guess. So you could have a borrow checker as a plugin somehow. Yeah. John Blow got really mad when I joined his stream and asked if Jai had header files. Jai does not have header files, right? All right. But speaking about header files, sometimes having header files is actually nice. Because one of the issues, like when you want to like see like what the module provides, right? How do you figure out what it provides? You can generate documentation maybe, and then like you have the header file there, but what we want sometimes is to like enforce the interface, right? So a language like OCaml here has the thing which is the special files called MLI. These are the interface files. It doesn't have headers. It compiles every single file on every compiler run. Oh wait, really? It is not even incremental, Jai? I did not make incremental stuff at all yet, either. And it compiles 100,000 billion lines of code a second or something, right? He proved incremental is bullshit. Does Jai have generics? Wait, hold on. He has a way to generate code, right? So it depends on how heavily you rely on that, because like, I mean, yeah. I mean, like if you are generating a shit ton of code, then your binary is going to be bloated, so you also don't want to do that, really. It has generics. Does it monomorphize the generics? Well, or are generics implemented in the same way as like in Zig, where you basically have a function that generates a new function? He has tooling to view the binary size due to monomorphs, so it does have monomorphization. Okay. Yeah. I don't know. I feel like maybe he proved that you can write code without like making the code too generic or something. I don't know. Like, I'm skeptical. I think John Blow just maybe writes code in some specific way, which does not. He uses generics like water. Okay. Well, that's interesting information then. I would need to try Jai. I will wait for it to be released and then I will try it, I guess. How else do you get Jai before it's released? You need to write an email to him. It's okay, I'm not in a rush to try the language. It's not going to stop me from making my own language at this point. If I did that like a year ago, though, then maybe Kast would not have been created if Jai is that good. But we'll have to see some if there is anything, which probably there is. Like I said, the type system is not as strict in Jai because of no borrow checker, no effect system, and all of that stuff. It's a low-level, statically typed language with no garbage collection. Just C but better, according to him. Well, I mean, Rust is also just C but better, or is it not? Zig is C but better. I guess I guess Zig is closer. But at this point, like, once you have like generics or comp time or whatever, is it really C anymore? Zig is somewhere in between of the C and C++. I don't know. There's a lot of like it's very far from C, I would say. C doesn't have like type inspection, compile time evaluation, and generics. There's like a lot of things that are not present there. C has philosophy. I don't know. I'm not a C programmer. So yeah, I would just treat Giant as its own language and Zig as its own language. And yeah, and stuff. You say Rust is more close to C++, but Rust is something in between C++ and Haskell, in my opinion. Whatever that means. I'm not sure which it is actually closer to. Probably to C++, but... Alright, anyway, so if we have this scope in, like, the thing here... detect duplicate parents here. So duplicate parentheses are going to be removed. Here. So in this case, we are just going to say that root children est tuple unwrap single unnamed. This is my child. And we just go directly to printing the child, right? So just do print AST child. How do I figure out if the parent is wrapped or not? Rule wrapped. Wrapped. Print parts. Wrapped. Wrapped. Oh, wraps is over here. Yeah, okay. Print group. So I guess I have this if not here, but like over here somewhere. Wrapped rule is the rule. Yeah, that's what we do. And then we print the child. Function print AST has type, filter kind, parent option. Parent is some RAI straight from C++. That looks very similar. Lifetimes, I don't know what else. I mean, there is like a lot of stuff which is low level. But is RAI like only present in C++ and Rust? I guess it is mostly known in like from C++ anyway, even if there are any other languages. But yeah, I decided not to learn Rust at one point when I was 18 and never picked it up. D-Lang has RAI like C++. I don't remember. D has a garbage collector. Well, I mean, like when I used D last, it had this stuff which is garbage collected, which means that it did not have RAI. It has the finalizers. D-Lang finalizer, I think. Not destructors, so they don't necessarily run at the end of the scope, but like when the object is about to be garbage collected, which is different a little bit. But D did have something like defer, I think, like in Go, I guess, right? You have the defer statements, which allow you to do the thing. Child, root, children, unnamed, child. Oh, this is a child, right? I need an AST here. AST, child, expect AST. There we go. That's what we want. Okay, let's see if it works now. So we're just going to say Kast fmt functor like this. Okay. I think it works. Let's try to start the language server, and let's just do this directly here. So if I just do this basically and then save the file, then it's going to be reduced to a single thing. Yeah, there we go. There you go. Bum, 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 bum. Nice. Remove unnecessary remove duplicated parentheses. It's hard coded here, this thing, but it's okay, right? For now. At some point maybe we will have less hard code. All right. So now that we have this, what is this noise? What noise? So yeah, I wanted to like go into the macro things. Or let's actually perform the rewrite, right? Of the yeah, let's make sure that all the function calls use the thing. So we're going to rewrite the entire code base, all of the Kast files. We're going to rewrite the old apply with the new apply. And we're going to do this in place. We're going to change everything. Okay. So this is all of the code. So now we, yeah, that makes sense. Should I actually check this? Let's see if the code still works, I guess, is the important part. Kast. It seems like it works. Let's though, now that I have changed this, we can also change the syntax rules. So that we don't actually have the this old syntax anymore, right? And we change it to the new syntax completely. And this is any, and apply with no args is something that is also not needed. So we just say that this is now the new core apply. There we go. That's what we want. And now we try Kast. And it seems like it still works. Okay, good. Good. And maybe now we can like move this thing around because calling functions with parentheses allows me to do some things that I could not before. Basically, it should have the same priority now as the dot operator. Right? So if I call now, if I do now f dot x, right? If I do now f dot x, this is not even parsed because it's expected end of file but got a dot. Right? It does not parse even. But it should. So like we have a bunch of things which have the same priority: the dot operator and well, I mean, yeah, the dot operator function application. Maybe there is something else. 70, yeah, generic application, and dereferencing, right? So we say something like f, and f is a generic function. We do say f int 32. We call this function, and we do say like dot x. Call this, and then we also dereference, and all of this is just done in order. Is the idea. So we move this to have priority of 70. Let's see if this still parses the standard library. Now it does not parse the standard library anymore. Okay. Unexpected semicolon. This one. Unwindable loop body. Oh, wait, because this is now a function call. I see. Right. It thinks that this is a function call. But it is not. Actually, how do we, like... I mean, this over here is a pattern. I think I want maybe like a do keyword here to differentiate. Is there any other alternatives? I mean, any other things? So that is, so yeah, I moved this to be below these things in priority. Unwind token value. I think this can be lower priority, yes. And if I call the function now, should be fine. With return should be fine. Unwindable token body. Yeah, this token is supposed to be the pattern. But I can also just say that this has a required parenthesis also. 60. As there's also reference. Colon. Is this the only one unwindable? That should be a higher priority than this. Let's do 75, 80. Let's see what's going to happen then. Boom, 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 boom. Then... This is not... Oh, okay. So now I try to unwind to this token with this value, right? And it thinks that this is a function call instead of this being two separate values is the issue. Okay. That can be... Maybe I need to like just change the syntax here. Also unwindable token body. I can like have a colon here or something. I kind of like the colon, actually. Because this is like a named block, right? So in Rust, you do something like this, block, colon, and then you can like break block. So that is what unwindable for me is. It's just unwindable block. And then we like unwind block with value. We can break block with the value like X here in Rust too, right? But what if this value is the unit, right? So in Rust this can be like this is just a label. But for me, we can store this in a variable. So this can be any value. And so it can be a value that is returned from a function, I guess. So how do we differentiate? Is this is part of this, or if this is the value that we are unwinding with? Keep old syntax to rewrite again? Yeah, we can. But what should the syntax be changed into is the question, you know? We can think about it a little bit. Unwindable is a long keyword, but it is like... It's supposed to be used from inside of another, like, syntax sugar, like a for loop, for example. creates unwindable blocks. Are you too cool to call it a go-to? Well, it's not a go-to. It is unwinding the block. It is going to invoke all of the destructors, I guess. It's going to drop all the values. So it's not really a go-to. But it is kind of like similar to a go-to, I guess. But it's not just goes there. It also does some things while going there, you know? Which is called unwinding. That's literally what it does. We unwind the stack. So I suggest that we have a colon here. I can add a colon here then too, right? Although, wait, hold on. Now I don't like this because we use the colon for doing the variant types, you know, like some value or none, right? So what if I want to unwind with none, right? Well, I mean, now we have a double colon here, so I guess it's not really an issue having a double colon. Yeah, having a double colon actually is not an issue here. Or is there any other better alternatives? Another alternative is to unwind and like actually require the parentheses here, you know? Or like unwind f with none, or like introduce some kind of a keyword there. I can make this very high priority, so if this we want to be a function call, then we would just have to wrap this itself in the parentheses, you know, to figure out what are we unwinding into. I guess that actually works. I guess that works. We just make this higher priority. Then I don't even need to rewrite anything. I don't know, let's try not to introduce the... not change the syntax if I can, maybe. So I just say that unwind is the thing of like pretty high priority. Well, I guess also of the priority. Wait, but now we want to have a reference, right? I want to unwind with a reference, right? So if this was lower than the reference, and then these things. That makes sense. So I would not be able to do that unless I require parentheses, like I said. Can you have nested unwindables? Yes. That is like that's very similar to the right. You have like outer, and then you have inner, and you can break out of the outer block, right? But it's more than that. Because, like I said, we can store this thing in a variable, and then we can basically also... the returns from functions are implemented in this way. Return from functions just unwinding also. And this also means that we can return from inner functions and do other things like that. Right now it does mean that I can store it in a variable and try to break out of the scope that we are not inside right now, but that is supposed to be fixed through the when I have the borrow checker, basically, because that's going to be checked similarly to the borrow checker. How do you specify to where to unwind? This over here, we say unwind. I call this token here, and this is the value, right? So this token is the token of the block. So when we create this over here is introducing the name of the token, right? And then over here we return to it. So we can say this outer, and then we have unwindable inner, and then we can unwind to the outer block with the value. and that is going to be the value, which is the result, you know, value, and which we can assign to like the thing. This is our actual value. This is what you can do in Rust, and this is what we can do in Kast. Maybe requiring parentheses here is not a bad idea, actually. So we want to rewrite this, right? Wait, what did I do already? Because I have I have moved my function application up here, and so this doesn't parse. Oh, but it is going to. No, it's not going to be parsed anymore. Wait, what? Let's comment this out. The issue, once again, is that we cannot parse because this open... Oh, this open parenthesis is unexpected. Oh, wait, we have unexpected open parentheses now? That makes no sense. Unless it links me to the not correct place. There was a point where it was parsed, right? Can I go back to that one? We keep the function application at the old priority of 50. Is that right? Unwindable was also at 50, or that one was at 60, I guess, right? Yeah, so this parses. Okay. What happens to the scope of the body of the function when you unwind? You unwind whenever you unwind a scope, you free the scope, right? You drop all the variables that were there. Although I don't really have the drops right now. So yeah, but it's supposed to like call the destructors like in C++. Whenever you quit the scope, you call the destructors. That is all. Okay, so this works, and it stops working. You thought it was something more complex? You would just call that exiting scope? Well, it's called unwinding because it's exiting multiple scopes, so it unwinds the stack. It's not a single scope that is going to be exited, but everything until the named scope, which name we are given, right? So we're giving names to scopes basically, and then we are exiting all of the scopes until the name is the name that we want to unwind to, you know? Also, another thing that is doing similar thing is exceptions. So in C++, when you throw an exception, you're going to also unwind the stack. So you're going to exit your scope, and you are going to try and find the scope which has the exception handler. And you are going to automatically exit all of the other scopes. So that is also a feature that can be implemented using the unwindable mechanic. So we want 70. Let's do, let's see again. We want 70, camel, run. Unexpected semicolon. Yeah, that's what we had because we have unwindable. Okay. I guess maybe we like rewrite and then... Maybe we rewrite and then we change the priorities then, right? Is the idea... Yeah. Wait, hold on. 70, 80, and this one also is 80. Is this going to work? It doesn't. Field label must be identifier. Oh wait, yeah. Because now if we have a call, yeah, now the function, now this is not correct. That's right. So like the variant types must also be of higher priority. Makes sense. Higher priority than the function calls in all of these other things. 75. And now we have the okay. Yeah. So yeah, similarly to the function calls, we also have the data associated with a variant to not require the parentheses previously. So do I want to require the parentheses here too? And then let's do it. Okay, so I'm going to make this back at 62. We want to rewrite the variants to also have that, right? Yeah. So this back to 60. This unwindable and unwind. We want these to be 60. Function call 50. Let's see again. Kast. Wait, what? It was parsed earlier, right? Oh, we have a parser. I think this over here is erroring. What did I do? What did I just do? Is the syntax defined incorrectly now? We have an error over here. Duplicate rule. Oh, wait, we have duplicate rule. Wait, why don't I see the duplicate rule then? In my thing. Because it's unhandled effect. Oh, okay. Yeah, we have duplicate rule somewhere. Oh, variant. I copied it. Yeah, there we go. Makes sense. Okay, so this is parsed now, and I want to rewrite these two things, or rather, like the variant with value is we want to rewrite this. New variant. I want to require parentheses here. Values any. Close that. Okay. We want to rewrite core variant. New variant. Okay. Now we say that this is core variant. Remove this. Move this with the priority, which is the priority should be like higher than all of these actually, right? So it's going to be priority of 90, I guess. These ones are going to be 80, and this one can be 70. The hardest thing about the syntax is figuring out the priorities here. Okay, it works. Okay, nice. Let's take a look at the code, what it looks like now. What it looks like now. Let's restart the language server so that we can have the highlighting again. Anything that I want to change now? Maybe I need to look at the trip. This one is using a lot of variants and stuff. I'm going to miss the fact that we do not require parentheses, but I think this is what we have to do for inclusion of other like syntax. Is there like any data? Like why did Rust not like they usually for all their syntax changes they have some rationale and stuff. Not use ML style function application syntax. Please Rustlang, why do you choose to name function fn and module mod? Don't you expect to read any programs you write? What? Are they saying that we should not use the shortenings? Should we always say function and module? Actually, I do use the module, not the mod, as my keyword right now. Let's just go over the code, see if there is something that looks weird. Also, we can try, like, I have this code, right? You know what the problem is? I want to rewrite my advent of code solutions, I guess. And see if they still work after rewriting and what they look like. So how do I basically I want to have two versions. Maybe like my rewrite should be done differently. We give it a one set of rules and the other set of rules, right? Like two versions of this file, before the changes that I applied and after the changes that I applied, and then I just rewrite from one to the other. That makes sense, actually. That's what I should do. That's what I should do, yes. Let's now commit. I think this should be good. We can get the old version of the rules by checking it from Git. Require parens for function calls. Yeah, let's so we can call it migrate, right? It's not even the rewrite, it's the migration of the syntax rules, because so we still have the same names of the things, but now the definitions are different. Yeah, that makes sense. So instead of rewrite, we call it migrate, which is, yeah. I think that's actually better. I think I can, like, have that. Migrate. So migrate then is going to be the two paths. It's going to be a single thing. Or I mean, sure, let's do it multiple times if we want to do multiple migrations, right? For some reason. So these are just going to be the files that contain the syntax definitions then. Migrate, rewrite. I mean, whatever, let's call it rewrite. Let's keep it called rewrite. A rewrite one. From into is rewrite, yeah. I will just not have the rule into, I guess. How many lines of code was the Rust version of Kast? 17,000 lines of code. It is smaller now than my OCaml rewrite. Right now we have almost 20,000, but it's basically like the same size, because we almost, I mean, we have more features than the Rust version at this point for sure. And we have almost 2,000 lines of Kast code. We also have Kast code in the Advent of Code. How much lines of code is there? Kast. 3,000 lines of code for the Advent of Code. So I have already in total like 4,000. There's also the Twitch bot, right? So Kuvi bot also has 300 lines of code. Yeah, something around like 4,000 or 5,000 lines of Kast code already. So I don't have the rule into anymore. We just have two rule sets. Let's just have this. From is syntax rule. No, it's not syntax. I want parser. Rule set. Parse. I want to like parse the rule set from. Oh, yes, parse lines, right? Yeah, sure. We can say source. Read from contents, and I'm gonna say into is rule set parse lines into, like this. So we have two different syntax rule sets. Which means that I need to parse using the original rule set, by the way. Yeah, over here we say the default rule set. the thing that we use to parse is the first rewrite, right? So I need to match rewrite with first. Then it's going to be then it's going to be parser rule set. Let's say parse a rule set first dot from. Otherwise, it's this parse rule set. Parse a rule set Yuri is just this. I guess I don't care about the from here actually, right? I just care about the into because we already have the parsed AST here. So this should be parse rule set into. How did I end up on OCaml though? I was just trying it out as a language because I try out languages sometimes, you know. Before OCaml, I was trying Zig, and there was like a bunch of other languages that I tried. You know, trying languages is fun. But like I said yesterday, I think OCaml was just like popular on Twitch between the top streamers for some reason last year or 2 years ago, somewhere at that time. So I was wondering why are people interested in it. String. Yeah, so we don't do string equal this name actually, right? So all of the complex rules are actually going to be rewritten. That's right. If they are existing, right? So I'm going to match into parser rule set find rule opt of the rule name. So the new rule that we are rewriting into is this. So if there is some rule into, then we're going to do this thing, and if not, then we're going to do that thing. Is that all? Maybe that's all. Zoding introduced you to dlang. It's fun, yeah. Yeah, Zoding is also doing a lot of languages all the time. I wonder how much of that minute-long compile time was caused by cargo itself. I was profiling. Maybe I still have the file. I can Rust gives you options to profile your compilation times. Do I still have this file here? Maybe. Timings.txt. This is the one, right? There you go. Look at this. This is the compilation times. Some crate is just, yeah, this is finished in 1 minute 11 seconds. So we need to find the crate that actually was compiling for the long time, which is the crate containing all of my logic. Yeah, they're over here. Total 66, right? Over here. You can see 4 lines here. The type check crate, it was taking 20 seconds. MIR borrow checking took another 20 seconds. Monomorphization collector graph walk is 20 seconds, and generate create metadata is 20 seconds, right? And also each of these like introduce a lot of gigabytes, right? It's because I use a lot of generics, so like it kind of makes sense. There is a way though, like Rust can be written in a different way, but I don't like thinking about how should I like. I just want to write code. I don't want to think about how to write code so it compiles fast, you know? Okay, how do like git checkout had how do you check out the previous version of a file into a different file? Git checkout help. You check out tree-ish. Do you do like this path spec from file? No. This gives you the path spec. Alright, this is what ChatGPT is created for, right? How do I check out a previous version? What is this? Close version of a file in Git into a separate file. Just git show. Yeah, that's what it shows me, yeah. I thought the git checkout would be able to do that, but that just like makes the file to switch to a different version, right? So we do had like this, and we do source, syntax, default, rules, into old rules, like this, right? And then we can like div old rules and source syntax default rules, right? So these are my changes that we did, and then we can, and then we want to do cast fmt. No, we want to do like fd fd extension ks in the home project advent of code 2025 contains path separator and will not lead to any search results. That's the search pattern. How do I make it the directory? Dash d? No, manfd. Oh, it's pattern and then path. But in that case, I did not have the pattern at all. Base directory. Change the current working directory of fd to the provided path. Base directory. Okay, so these are all of my cast sources in the advent of code, and then we just do execute cast fmt rewrite. From is old rules, new rules is source syntax default rules. Oh, dot is just like the pattern. Okay. I can't find the root of the current workspace project. Would you like to create a new Dune file? Oh, wait. Yeah, okay. Cast. Because cast is just alias to Dune run. Hold on a second. Cast is alias to Dune run. Interesting. So I cannot change the working directory there, right? Yeah, I mean, I should not change the working directory. I want to, like, I don't want to change the working directory. Yeah. We want to just... We want to just give me all the files, right? Okay. Unmatched value group in target syntax rule. Unmatched value group in target syntax rule. So this is actually trying to rewrite every single node, unlike before, and maybe I need to improve it now. Unmatched in the targets thing. Can I say over here something like try with e raise e? Can I say like log error while rewriting ast print ast? I guess I mean sure, let's do no, let's do print short. Whatever, let's just print. Let's see what is going to happen. There's just like too many things. I just need to find the top one. I will not be able to see it. There's too much output. Okay, fine. Let's just give it the let's just give it and then give it the span print ast span, and I will print the rule name. All right, so this one, the function over here could not be rewritten. Why? Oh, okay. This is because we have optional groups in the function definitions. Sure, let's make this work too. So core function is a thing which has an optional group which specifies the context type, and the result type is also optional. Yeah. I should probably just make it work for the full migration. Yeah. Also, another potential rewrite is when we reorder the arguments of the thing, and this is also not supported right now, right? Like, imagine if we, for some reason, wanted to rewrite all of our function calls from farg into argf. For some weird reason, right? Maybe there's some other syntax rule that we want to do that with. This is not supporting this kind of a rewrite right now. Not even improving, like auto syntax migration. So this is where we match the rule that we are rewriting into and our currently parsed AST. Whenever I see a value, I just give the value as is. But maybe I don't even care about this, right? Because I just need to print the group of the target rule, you know? Yeah, I actually do think so. And then we don't actually rewrite the value here. Because when we rewrite the parts, I know the children here. Yeah, actually, yeah, I know the children here. So this tuple is like we give every child AST a name, right? In this index rule. So for example, when you type ascription, we have the thing that is called expression and the thing that is called the type. So we have these as a fields in the AST node, named fields. So I can just find the field by its name over here. This is a binding, and this binding has a name. Yeah. Wait, do I even need the original parts? I don't even need the original parts then, right? I don't even need the original parts. But the original parts, they contain the comments, which I would like to preserve. There are comments. Comments are nice. Because if they are not part of that, we're not going to preserve that. But I guess we just ignore this value here at all completely. And we do not rewrite it here, but the value that we get is from the binding, which means that also rewrite parts matched rule. This should give me the original children, right? Which is AST part tuple, I guess. So we rewrite using the new children. Let's children, and we first rewrite the children recursively, and only then we give them as argument here. It's not SST child tuple. Okay, yeah, that makes sense. So now over here, I don't rewrite twice, and I don't need a hash map of the things that have been rewritten anymore, by the way, because of this. So I can remove this rewritten map. Doesn't need to exist anymore. And simplify the code a bit. Okay, right, but this value, since I don't have the value here, this is going to be the one. So we have a binding. Binding have names, and I need to like get that one. Oh, so and yeah, and if it is the one that is unnamed, then I would want to have the index, right? Unnamed child index is an int then. So we start with the 0. Just pass it here. In this case, though, we're going to advance. Actually, I don't care if this is a value, right? Even this can be anything. If I have the value in the result, then we are going to write it there. Yeah. Rewrite AST value. So value is going to be children. It's going to be children. Get member, and the member is match binding. Name. it's unnamed, then it's name, and if it is not, then it's just unnamed field. Which we are going to modify and increment here. And then return the index. Like that. So the value now is a child, right? But in this case, since this is a child, this must be the child which is an AST, because we are expecting a value here. And then we do something similar for a group. The groups, they must oh wait, the groups also are optional. Okay, sure. Maybe it means that I want to I don't want to copy paste this. Wait, this is not even the rest part. This is just the parts. We just ignore the values and group is in the original one. Not the rest even. Parts. I guess I can make this always be an index, which is going to be mutated. So we're going to get the value of it here, and so over here we say unnamed child index. Okay. So then this can be called. Get member binding name. Yeah. Get member name is function like this. This returns a tuple member. This is a string option and tuple member. There we go. So if we have a group, now we want to find and like the actual group. The group is going to be children get member of the rule group name, and we expect this to be a group, and then we rewrite this. And then we do this unnamed child index. Okay. So I think this now should be able to migrate. Also, now if the first thing is a value or something, then we just ignore the values and groups that are original ones, right? Yeah, so I think this is not even a branch that needs to exist anymore. We just say that value rest parts and whatever for group rest parts and whatever. In all of those cases we just rewrite part mesh rules and mesh child index children rest parts rule parts. What is this keyword? Keyword is multiple tokens keyword. Match first. Unmatched value group. Yeah, I don't care about this actually. We just... The only thing that we do is if we have whatever, and then we have... So if we have white space followed by the rest of the rule parts, then we just rewrite unnamed children rule parts, rest of the rule parts. No, not the rule parts, parts. Like this. And then if we have a keyword with the rest of the rule parts, then I'm going to need to create the keyword here. And then follow that by rewriting the rest. And this does not need to exist anymore. Is that right? Exception not found. Not found. Get member tuple get. Let's say get member. Let's say that get member is going to actually return the AST child. This is going to be function name, match name with this. This is going to be my member. But then we are going to say children tuple get member. That's the same code as before, right? But now we are going to say match. I guess we're just going to do get opt this option unwrap or else fail not found tuple member print member. Context is not found. That makes sense that context is not found though, right? Because this one is optional. This one is optional. So like, because we are trying to have a group, and groups, they have quantifiers. Quantifier is the optional, right? So we can just name things. Later, we are also supposed to have like repeated groups in the syntax definition and stuff. For now, we just can have optional groups. So get member should, I guess, return an option in this case. Over here, though, we are going to say that it's not found. I don't have the member now. Okay, fine. We return the tuple member here after all. Fine. So that's going to be like children, people get this. This is member. What is the engine structure for your game? That is something I entirely understand. The engine is like I don't like you like it's not really an engine. It's like a framework, I guess. The engine just gives me the way to to draw stuff with OpenGL, to handle input, to like do like windowing input, graphics, very low level APIs, and I don't know. That's it, right? You just need input and graphics and audio. Yeah, I guess. I don't know what exactly is the question. Which part are you interested in most? So in terms of graphics, I expose like not exactly like OpenGL, but a safer abstraction on top of OpenGL. How are the levels made and initialized? Well, I just store the levels in a file in this, like, I don't know. The levels are just like structures that we serialize and then deserialize. I mean, we can take a small distraction and go to the link cider and level. That's not part of the game engine though, because the level can be even loaded even if we don't have the game engine, because we can simulate the game for yeah. Over here we have the versioning of the levels. Something like this. We just have levels stored in a bunch of layers, and each layer has just a list of entities, and each entity has like a bunch of properties. That's all. The levels are scripted. I wouldn't call this a script. We do have a way to do scripts though. So the trailer that you see constantly running in the corner is also done programmatically. Can we kill the Rust Analyzer? I hear my fans going. Why can I not kill it? Oh, it's Rust C. Can I like stop kill Rust C? I think it stopped. Finally. Your Hightail looks weird. Also because I'm not playing Hightail. You said yourself that the game is going to be bad at release, bad cop, so like I'm trying to wait until it becomes good, you know? But yeah, I was like just talking about the way we do the trailer for the link cider. Here's what it looks like, the trailer. We have a bunch of sections, so we're doing a zoom in into the like a specific level that we have saved the replay of how we should move, basically. in the specific section of the trailer. So this thing is scripted, I guess. We have a script for the video, and then we can just run and do stuff. Yeah, we have trailer as code. I was joking about Hightail being in Minecraft from Timo, but it looks impressive good. Well, I mean, it is Minecraft 2, basically, right? They just couldn't really name it that, so they decided to name it Hightail. How different is it from Minecraft, though? Like, now that you played it, Bad Cop? Is there any actual differences? Like, I mean, as I understand it, it's just like basically Minecraft plus like more things like to explore, and like an RPG system or something like that, which is something that Minecraft should have had anyway, so that like there's something to do, you know. Maybe it's like more adventure oriented. But you still can do everything like that you could in Minecraft. Maybe like redstone is not there. I'm not sure if redstone's there. Vintage Story is a better Minecraft. I think Vintage Story is like focused on survival instead. So it's Vintage Story, or is that not the thing that started out of the Terra Firma Craft? Vintage Story. Yeah, that's the thing, right? That's yeah. That is not Minecraft. Well, I mean it is, but the main game mode, I guess, is that like specific mod, which is supposed to be like you like play in the Stone Age, and you need to like do all of the weird things. There's a lot more animals and monsters. Yeah, like I just feel like Hightail is like Minecraft but more content basically, and just implemented better supposedly. Like, is there a reason if Hightail is there to go to Minecraft? Is there something in Minecraft that you cannot do? You think they're quite different? I've not seen Minecraft is going to be Minecraft. But what does it mean to be Minecraft? Can you not just make Minecraft in Hightail now? By removing the content, basically? No? Or is there something more? Maybe I just don't know, because I have not tried it. Okay, group. Hightail graphics make it feel different. I don't know. I feel like I mean, yeah, maybe. But I think that graphics is like a syntax of a programming language. It doesn't matter. It's the semantics that matters, you know? It's always nice when you have better syntax, but better is I guess subjective. In Minecraft everything is a cube, but in the like in the later updates to Minecraft, they introduced all of the new like things, especially like horses. They feel like they're not as blocky as like the old school animals. There's stuff that isn't exactly a cube, but it's vaguely cube. Pretty far diverged from cubes. I don't know. Maybe. But they're just graphics. In terms of gameplay, is there any differences? Like the only thing that comes to mind is like the redstone, whether there's redstone in Hytale or not. It's the same as how vanilla Minecraft feels from modded. Yeah. So modded Minecraft is still Minecraft, is what I'm saying, right? Which means that Hytale is still Minecraft. Alright, let's try to make progress here. I'm trying to do the syntax migration. Member. Oh, did you find the ultra hardcore mode in Hytale? That's the reason I'm not playing it. If there is no ultra hardcore mode, is there a normal? Is there like in general the hardcode, the hardcore mode in Hytale already? Have you figured out the end goal, like something similar to the dragon, where you get the credits? So we can start speedrunning it. Get member, rule group. Okay, so this is a triple member, right? So I want to match on the rule group quantifier, right? If it is some optional, then it is an optional group, right? If it's none, then it is not an optional group, right? So we say that let rewritten. I don't know. I guess we just I don't know, let's call it expanded maybe. So we do expanded followed by the rest of the things. So a lot like expanded, yeah, sure. Expanded like this, not like this. No, expanded is like a list of the things already, so we need to append the lists. Because in terms of an optional group, it might not exist. If it's not optional though, let's do this first. Should be easier. Where's the syntax error? That's not a syntax error, is it? Oh, camel. No, this is a... I mean, wildcard is not expected. It should still be formatted though. Why is my OCaml format not formatting? I think this over here. There we go, I found it. Since you play making puzzle, have you played Zachtronic games? No. I don't think so. I mean, I did launch Infinite Factory. I know about these two games, but I never played them. No. Expecting language dev to be a gamer? You think I'm not a gamer? What do I need to do to prove to you that I'm a gamer? What do I need to prove to you? Let's open Steam. You think I'm not a gamer? Can Steam open? Alright. We'll wait for it to open. It's thinking. Oh, there we go. Let's see here. How do you sort your games by the amount of times you played them? Sort. I don't know. I mean, how about 2200 hours in Factorio? Is that enough to be a gamer or not? I would need to, like, choose another game. CS2? I don't play CS2 too much. 700 hours only. How much do I have in... Nah, not a lot. How many hours do I have in Project Zomboid? 577? Yeah, a little bit. I thought I would have more there, actually. You can see that in the profiles. Wait, that's his children playing the games? He's not gamer, he's lying? My child is like 1 year old. Alright, you guys are distracting me from working on my language here, okay? Hold on. What am I doing here? So we have the optional groups and non-optional groups. And in this case, group is going to be children get children tuple get member expect group. So in this case, it is not an optional one. And we give it the group. Like this. So this should be a list of AST parts. Right? And in case it's an optional, it's going to be similar, but this thing is an optional, right? And we do option map. And we like... And we just match children tuple get opt member with some group, and then we do group is group child, group is child, expect group, none, and then we do empty. Yeah, there we go. That should work, right? Kuman is a gamer, I can confirm, one of the world's finest hands players. Oh, right, I have the world record in one game at some point. You don't... You think that it's my children that play my games, right? Yeah, let's see, where's my world record? Oh, you found it? That's not the world record. What? No, that's the wrong video. Don't. No. Hold on. No, that's the wrong one. You know, I actually have like a lot of like Hans was made by some like famous like Turkish YouTuber. There's 84,000 views on the on my thing here. Yeah, see? Gamer. You miss Hans? Should we go back and reclaim the world record? Hans? Hans is this thing that we're playing as. Unexpected. Oh, we have the unexpected thing when after we do this. That actually makes sense. I just need to say in place. Let me take a look at what is currently in this thing of them. I mean, lazy git, I guess. I still have some things. Wait, what does it change here? I just added a semicolon. Yeah. Let me just to make sure that I commit that. Something. Okay, and then we do this in place. Okay, it succeeded. Fine. Let's take a look at what changed here. This looks not correct. 4, and then we do have a new line now for no reason. Speedrunner turned into language dev. Yeah. For day in this. Why would it do a new line here? Well, I mean, we can just form. Oh wait, what? That makes no sense though, right? Maybe I can like do the cast format again without the rewrites now. And if I try to format the code again, what's going to happen? Oh, the code is now not being parsed. Unexpected let over here. Oh yes, because I guess it moved this bracket. Into the comment, even although it should not have done that. Well, it's because this bracket was over here previously. How much of a PvP player? Not much, no. I did like playing the battle royales though. Like, I had a lot of time in Apex Legends and in the Warzone. Call of Duty. I like how my stack traces are. At this point, I should just, like, disable them always. Unexpected let. Over here, same thing, basically. Unexpected closing one. This closing one is supposed to be... what is this one is even supposed to be for? For the SLs. So where is this closed? But this one is closed over here. For some reason. This one is closed over here. I think this must have been like that. That makes sense. I should probably not fix it by hand. If I fix my rewriter here, that would be better, right? So what happens is that I'm printing something after a comment, which turns it into a comment. Yeah. That is my formatter. Previous was comment. Previous was comment. Is comment true? If is comment... if is comment or previous was comment, then if previous span finish line is this, then position beginning. Have you been streaming for a while? A couple years, yeah. How do I fix this? So, it is just my formatter. My formatter in general is not very... like, there are some issues. We are not preserving the comments at the end, for example. I think this should be printing a new line. So this if is not happening, right? Because the previous thing that I was written, that I wrote, the previous thing that I wrote is equal to the thing that I'm trying to write right now. And first thing is not the beginning. So yeah, but basically this is the if that matters, right? Yeah. I think it's just the order, actually. You know what? I think it's just the order. Let's revert all the changes in the advent of code, right? I think it's in my rewriter. We need to first check if there was a comment. Then we're going to write that first. Like, first we need to check on our actual thing for the comment, if there are any comments. Yeah, I think like the comment is the first thing that I should check for. It's a little bit weird. Let's try this one. We are going to rewrite this again. Let's see if this is going to work. Kast. This. No, this does not work. Still is the same issue, like after the comment. So, what was here previously, though? This is day 1, right? Not this, this. Day 1 of the advent of code over here, right? So we have a comment followed by an if. So the parts that we have is the comment followed by if. And I need to like preserve the parts in the same order in terms of the comments. So if I see the comment, then I write it immediately. Wait, but this should work, right? Okay, let's have a simple example, actually. You know what? Let's have a simple example. Let's have a test. Let's write this, you know. Let's have a comment. And then we have this, right? And then we do cast fmt, rewrite, old rules, syntax, default rules. Examples test, right? Well, this actually worked properly. Is it because we have something else there? Let's have like this thing. Guess I cannot do the highlighting, but yeah, this turns it into a single line, and we can test it now. Let's maybe also try to minimize this. If I remove this, still on the same line. Over here, does it have to be this, or can it be 2 plus 2 here? 2 plus 2 is on its own line, so it kind of depends on what we have. So if true, then this. Okay, what about the semicolon? Okay. What if I say F? Okay, so it's specifically about the if for some reason. Inside of a 4, does it not have to be a 4? Probably not. If I just do this, then it still is on the same line. Okay, so this is the simplistic example, which puts this comment on the same line. Does hunt music still haunt you in your dreams? No, not really. I don't remember it anymore. It has been too long. Actually, there is like a different game, by the way, similar to Hunt's, which was released recently. Like... let me find it. This thing. I've been playing this one off stream though. Because I don't really play games on stream anymore.
Well, Egg, here we go again.
Oh, that was ugly. You'll do better next.
I don't know. I'm not going to play it on stream though. I guess we can only play Factorio on stream now. And yeah. And I'm not going to do that also until we have enough progress on Kast. Alright, how to preserve this comment? Why play Factorio when you can debug? Right. How about we actually do debug? Okay, let's start then by saying cast parse examples test, right? We need to figure out what is being parsed into. But the cast parse does not tell me where the comment is attached actually. Yeah, it does not tell me where the comment is attached. Is the thing. Comment. The rest of the parts means that we have it as the comment. So if the first thing that we see is a comment, which it should be at some point, right? Because it's not a trailing comment, it's literally the first thing in the file. It's literally the first thing in the file, then it means that the comment is still there. Is it because maybe I'm having the span information wrong. Let's take a look at my spans. Because keywords, yes, because keywords have new spans. Span is beginning of. That is the issue. That is the issue. I need to find the spans of the keywords. It should not be the beginning. It should be... Well, I mean, it is this because this is the generated one, right? Maybe it's in the formatter. We have this, right? We create spans with URI empty in the rewriter, so we want to skip them. So when I skip them, we say that it is equal to the previous span, which leads to me not printing the new line, right? Yeah. Okay. Is comment true for all of the comments before? But the comment can be like of two types. The comment that comments everything until the end, and a different one. And a block comment. I mean, right now, maybe I can just print the new line. I don't want to print the new line always, though, right? Formatter is difficult. Well, I can say I can do a hack if the URI is empty too. That feels like a hack though. I can only put the space after the comment if it was not a block comment though, right? So I need to like figure out the comment type. Do I have in my comments the comment types? Token comment. And we don't even do that, right? It's just a raw thing. I should probably know if it is the one, right? So comment type. Let's have this where comment type is going to be either a line comment or a block comment. This is a line comment, and this is a block comment. Okay. So now we can figure it out. So is comment is going to be token comment type option. Right? So we say if if is comment and previous was comment is going to be the same thing, I guess. Ref none. So we know that if we could know if the previous was a block comment, right? Right. I guess it is. Let's first match on the previous comment. You know. So if the previous was a block comment, then we always must print a new line. But if it was, I mean, no, if it was a line comment, then we do this. If it was a block comment, then we only print the new line if it was printed. Right? That is when we are trying to continue after we had a comment previously. So we do that. If I myself am a comment, only in this case, if the previous was not comment and I am a comment, I want to print a new line only if it was present, basically. Which is the same thing. Well, I mean, in this case, we do any comment. So for any comment, the logic is the same. So if we print a comment after something, then we only print the new line if it was present. That probably makes sense, right? This might actually also fix my thing. Where we didn't preserve the line comments at the end of the line, maybe? Let's take a look. So this printed properly, this formatted properly. Okay, let's restart the language server. Maybe let's just try something. So now if I say over here comment in the end, this comment is also preserved now. We are doing the formatting here, so like all of this is actually doing the formatting. And we preserve these things. Print hi. Yo. Now we require parentheses here, by the way. Okay, no, this still does not preserve the line comments. So the reason for this, though, is because this comment is attached to this thing, not to this thing. And we print the new line after over here. So that is not fixed, but in general, I did not introduce any new bugs, did I? Let's try to do. I don't have any actual code that we care about, so we just do Kast fmt. I just want to Kast fmt in place everywhere, right? Like this. But without the rewrite. Did this actually formatted any code? It did change something over here. It says dbg.print. Wait, what this code even is? Oh, it's because I'm printing two things, this one and this one. Okay, this kind of like makes sense why the formatting is broken. That kind of makes sense. So the issue is, previously I had my function arguments as just the thing in parentheses, and it was formatted separately from the function definition. Over here we say /n/t. This over here is what controls the formatter. So we do the wrapping if anything was wrapped. So if my original source was written in multiple lines, then the entire thing is going to be written in multiple lines. Yeah. I need to do like maybe I just need to do the same for my function application over here. Yeah, because it just never wraps, but the wrap should be if any, and we should have the same thing. Just this is called arg. Although now we have another problem. So we have trip.join, and the dot join is now on the new line. The reason for that is because I'm calling the function trip join, right? No, we are not calling the function trip join, because the dot syntax and the function application now have the same priority, and they're just evaluated in order, right? And the way I'm formatting the things of the same priority is whether the thing is wrapped depends on the entire thing now. So because this is wrapped, it means that it thinks that this should also have a new line inside of it. Because if we have like a long chain, you know, like A, B, C, D, like whatever, like this, right? The idea is to print every like dot on its own line here. Although, do I want to do that actually? Maybe. Maybe objects.field should never be wrapped, actually. Maybe this should actually never be wrapped. The generic one should be, though, if any. Similar to the function arguments, right? So this is how this is formatted now. Kast. Restart. There we go. This, I like this formatting. But the issue now also is another one. If I have dbg print and over here I say underscores to explicitly say that this is the generic argument like this, now it's going to put this on the line, right? This is the similar thing because instantiation is the same, priority is the application. It does this in order, right? What happens now if I do, by the way, like dot foo like this, right? And that's not right. I guess the way we do the formatting should also be done differently now, right? So the idea of the formatting, which is grouping the syntax nodes of the same priority, is that if we have something like, you know, 2 plus 2 plus 2, and these are like very long expressions, then we would join it like that, you know, in the formatter. So basically, if I have the line break anywhere in the chain of the things with the same priority, which are associative, then we break every element in the chain. So, but in this case, I want this to be formatted like That should be on its own line. Then I have the function arguments like this, sure. Wait, where does the dot actually go? Maybe the dot actually goes here, and that's fine. So the only thing that I want is to make sure that this only care about themselves, I think. Oh yeah, that makes sense. I think these things should only care about themselves. So I think we need the new formatting style. We have never, we have if any. What else do we have? Syntax rule. Syntax rule. We have the wrap mode. Wrap mode is a never, always, or if any. But I think so if any is doing it with associativity. But I think maybe we should call it if any associative. You know, and if any non-associative, which only cares about this AST node itself. I like that. I like that. So we have control over this. So if any should probably be just non-associative. But if any associative should be associative. Like that. So this is when I'm doing the formatting. Wrapped. Print white space wrap, print white space no wrap. When I'm printing the raw, yeah, sure. Yeah, so the question is, how do we determine if this is wrapped or if this is not wrapped? We say that wrapped is if the parent was wrapped and rule priority is equal to the parent rule priority, then wrapped is the wrapped, right? So like this is the associativity thing. But I guess I want to do this only when rule wrap mode is equal to if any associative. Only then we take the thing from the parent. Otherwise, we'll say false. So if it is associative and we have the same priority, then it means that we group them by the thing. Yeah. That makes sense. Let's try again in my functor over here. So if I remove the spaces here, then it's going to be printed like that. This over here is interesting. So we have the empty one, and the empty one is still being printed like this, which is weird. So the empty node should, yeah, the empty node, the empty unit is always, wait, not in this case though. Not in this case. In this case, yeah, this over here is also weird. The formatting with the empty inner node, I guess. Yeah, but for example, commas, we want if any associative. You know what? Let's make everything if any associative just so that it works like before. But the function application and the instantiation should just be if any the regular one. This one is not even associative. This one is not even associative. This one is not associative. This one. So it's a comma, a union. Or and pipes, math operators, and that's all. That sounds okay. Okay, so now the last thing that I need to fix in my formatter is this. So why is this being formatted like that? This is a function which takes as an argument the empty node. So, but why is this formatted properly? Because isn't this the same? Because is this not the same? Oh, wait, I know why. Because this thinks that this function application is actually wrapped. So it's wrapping this thing. So I need to wrap the group separately, actually. And to actually wrap the group separately. Because, like, we determine whether this requires the line breaks based on the still on the entire expression. But this should require the line breaks based on just itself, you know? Which means that, yeah, we don't care about whether this generic is broken into multiple lines. All we care about is this thing. So we need to have a group here. And this group should be wrapped if any. But the entire thing should not be wrapped. Actually, yeah, that's actually what we want. So function application and this. And maybe in some other places we have the function argument and generic argument as that. And this group. This group should have something. How do I parse the group? Parser rule. This is when we're parsing the rule. So if I have a group, we pick the token, and if it is this, yeah, otherwise it's none, and we don't have it. This is how we read the group. Oh, we can do like underscore is equal. Yeah, that makes sense. Because I cannot just have the groups like this. We need to give it either a name or an underscore. Like this. Restart language server command does not work anymore. I probably need to reload the window for some reason. Hello? Maybe oh, it still doesn't work. Oh, in the standard library it doesn't work. Expected AST got group. Right. Because this is now a group. Okay. Because I'm not flattening the group. Because I'm not flattening the group. Kind of a little bit annoying. But we do have auto syntax migration. I just need to like fix the formatter. So since this is a group, the compiler now does not see the argument field directly. It is nested inside of this group. Would be kind of nice if I just flattened my group though. Would be kind of nice if I flattened my group, which means that I want this. So with the optional group followed by a question mark. But I want this to be flat. Can I do colon flat? Maybe. And then it's not an actual group. Also this underscore equal. I don't want that. I wanted to do a simple thing and now I need to change everything. So is this what we do? We say that this is a flat, or maybe like if I just don't have underscore equal, this should be treated by a flat group. You know, but if it's optional, then that is kind of weird a little bit. It would like make every field optional, I guess. Kind of is fine, actually. Maybe this is what I want to do. Maybe this is what I want to do. We're just going to, like, for now, maybe panic if we have an optional flat group. How about that? Let's change the way we are parsing the rule. rule in the parser, right? So if we have if I have punctuation, so yeah, in this case, this is a named group, and we want an unnamed group, right? Yeah. So if I have a punctuation, which is this, so this over here should be just extracted into a function. This over here should be extracted into a function. I guess it should be like some read let rec part collect parts part some group part. Right, like this. So say we do this and group part is this thing. We advanced the lexer though. I guess advancing the lexer should not be happening. We do it over here. Okay, and in this case, if this is a punctuation, we just say that we return some group part, right? So this means that I can have a group part. But what is the name? I guess we need to give it the name. The name is like, so it is either flat, right? It's either a flat group or it is a nested group with the name inside. Name still might be absent. So this is like, how do I call this this property, which is either nested or flat? Nestiness? Nested? I don't know, let's just call it nested, I guess. So we don't have name, we have nested instead, and this returns group. Okay, but group does not have the nested, it has name. We should call this nested instead, which is going to be nested. Group nested, right? And group nested is either flat or nested of string option, which is the name. Yeah, that makes sense. .40 stream streak. For a penguin, that's impressive. Option print, DBG print. Fine, let's just match group nested with flat. Print group flat. Nested name, then empty group nested group this with a name. Yeah. Nested name like this. Parser rule flat unbound constructor. Okay, camel. And this is collecting the children. So after I have parsed the thing, I want to know my children, and we are going to flatten them, I guess. So if I have a group, it is not necessarily group parsed. Go in. Match go in. True, false. Collect children. Go in. What's go in? Group rule. Oh, we're already inside of the group. And we either have the quantifier or not have the quantifier. Right? So we know that we collect children. Collect children gives me the collect result. Which is parsed and children and remaining. So we collect children, parse, this, that. So yeah, we are parsing this as a group right now, always. And we say that the children is my original children. With a new thing, but this is only so if it is nested, okay, right? So we say match group rule and nested with nested name. Then we're going to do this. This over here being the name. So we assign the name to the value of the group. This is my AST group. But if it's flat, if it is flat, then I give it the group children. String option is the child list. If it's flat, then I just give the group children followed by all of the other children, and we like do that. Wait, but group children is tuple, right? Yeah, I guess I don't construct the group in this case. We only construct it in case of a nested. And in this case, we just have the group children. Oh, but parsed is a group. So we don't do that. Yeah. Then there's also parts. I guess parts though must be. Yeah. Okay. Hold on. No. We need to like match. Group rule nested over here on the top level. And then return this. Where this is the children, right? But this is going to say that parsed is going to be group parsed. Or should this still be a group? I don't know, actually. Hold on. Maybe this actually should still be a group. The part. I only flatten the children. But I can access the children in two ways now. In this way and in that way. Which is probably okay. Okay, the rule set. Added the rule set. We have nested, which we ignore here. If I have... yeah, and now this is my formatter, which is the rewriter, right? The rewriter member is get member rule group name. Oh, so yeah, this one is not necessarily is my thing, right? Member. Yeah, because the group might not even have a member in my tuple is the thing. If it is not having the member in the tuple, because it's flattened. Because it's flattened instead. Rule group parts. Some rule group. Group. Rewrite group. Group parts. So yeah, what do I do if I don't have the child? Well, I mean, I don't have the member even, right? This is difficult here, but if it's optional, then we are not going to support flattening of the of these groups. If it's non-optional, or maybe I should still have a way to get the groups even though they are not flattened or something. Lat member is let's do this. Match rule group nested. This is what we are rewriting into. I don't know what to do with the flat groups here. Maybe let's just ignore it for now. Because we're not doing the rewriting. Well, I'm not doing the rewriting right now. Okay. And why did I do this again? Because I wanted to have like for the group, like, okay, because I wanted to do this is just nothing. This is just a quality of life thing, I guess. Where I have groups which are not necessarily stored at the in the list of children. And now we want the groups to have the now we want the formatting to be specified for the groups, right? Yeah, now we want the formatting to be specified for the groups. That makes sense. I feel like I need to do this though. Kast fmt rewrite. Right. This is going to say, what do we do with flat groups here? What do we do with flat groups here? What do I need to do? I need to... What is this function returning? What am I trying to calculate here? The part list. We are just trying to calculate the part list. So we just... Well... And in the parser of the rule, that's the code that I was just writing, right? The parsed, we're still parsing it as a group. We are not flattening it in it over here. We are not flattening it here. We're flattening this tuple. Not this one. Maybe I can have a separate children without flattening, you know. That would be... That's... Nah. Well, I need to rewrite the group matched rule. We do want the rule, we do know the rule group. But this should be rewritten in a group, but we just don't have the group anymore, right? We don't have the group anymore, which means actually that I just rewrite the parts, right? Because it's flattened. This is actually easy, relatively, right? maybe. So the thing that we return here is just going to be rewrite parts matched rule. Unmatched child index. Children are still the same because we're flattened. Parts. And then we have the rule parts. And the rule parts in this case is going to be the rule group parts. But then after this, we need to also rewrite children. Well, not the parts anymore. Now we once again have like the remaining parts that were not parsed. Oh my god. Children parts, rule group parts. Like after I finish this group, there's still the remaining rule parts. So what do we do about those? Well, I mean, this is taking the whole parts then, and this one is taking no parts. It's not exactly correct, maybe. Well, the only thing that this is useful for is for preserving the comments. So maybe I just do that. Unreachable reached. Print parts. Yeah, so like over here where, yeah, we need to like do this. Because now we are doing the rewrite where something previously was grouped and now it's not grouped, and so it is weird. But we just make it not weird by yeah, we need to like have the same structure of the groups, that's all. So we have in the old rules now, also in the function core apply, I make this to be inside of a group similarly to the other one, right? And instantiate is also going to have this argument in a group for the sake of the rewrite. No. 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 Oh wait, what? It's because we expected a keyword, but we did not have a keyword there. The opening bracket. Unreachable. Wait, can I just fail here? Can I have unreachable to specify done in terms of failure? Unreachable format. Does the form matter? Suspended printer. Suspender printer is what I want. Yeah. And then we like fail. Unreachable. Reached. P. There we go. This should be cleaner. And I should see my error message better. Right? What did it say? Print unreachable reached. Fatal error. Exception use star print. Oh, it's because like it's in the middle of printing. Okay, unreachable reached. The parts are none and keyword this. So we want we printed so far this thing, and then we have the opening thing. So we expect to have a part which is a keyword, which is this, right? But then we do not actually have it because my rewriter did not do it properly. This one is a flat group. So this one is a flat group. But in my original parts, it was a group. So I do need to flatten the parts there too, right? I do need to capture the parts, but how do I collect them then is the question. Hold on. I think I need to, I think I will actually, maybe, I don't know. This is too complicated now at this point. And I should not be doing that, maybe. So the question is, how do we represent this in the AST, right? We have two representations. First representation is just having every inner AST as a field in a struct, right? With these given names. And another representation is what gives me the concrete syntax tree, I guess, which also has every single part, every keyword, everything stored directly, right? Wait, I don't understand still. My new rules have this as a group. Unreachable print parts. This is me printing the parts, the rule parts, the parts. I guess. Oh wait, hold on. If my rule part is a group which is flat, maybe this is what is missing here. Is if the rule part is a flat one, then yeah, I'm not. Yeah, since we want a part. Since we want a part. Dun, 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 dun. So I'm going to rewrite this. That is going to give me the parts, but that must be a group now. If I don't flatten them there, so I still need to do a group. But the group should have inside the rule parts and children. So I still need to return the group here. I will never be able to come back to this. I need to like think about it more, maybe to write it in a way that is going to be understandable later. So I don't want to have flat groups then. Is that right? But if I don't have flat groups, well, I mean, yeah, the only issue was that it was not a group in the previous rules, but we can just fix that because we can just change the original groups, the original syntax definition. Okay. Flat fail. I feel like I should have been committing though what I've been doing, right? I have like comments and stuff. Now I have the groups. So just say that flat groups are not done or something if we see them in the parser. And maybe eventually I will actually implement them. Flat. Right, so this over here is going to fail. Flat groups are broken. Guess I can keep this warning actually. Flat groups are broken, so we need to make sure that there is no flat groups now. The only one was in instantiation. Over here, make it to be like this. After all, and now in the old groups, we just need to make sure that they are matched for the rewrite purposes. So this and applying a function Like this. Okay. Thank you. I just formatted everything in place. Let's see what was changed. This dot construct backward forward. Actually, I like this change. And that's the only file that was formatted, actually. Okay. So I formatted all the code and it still is the same. Nice. And then I want to format the advent of code. Advent of code right now is in the clean state. Let's rewrite the old rules into the new rules in place. Okay. It did rewrite it. Now the question is, does it still work? Test. Of course it doesn't. Expected AST got group. Right. Okay. Is that the reason why I started to do this? It's because in the core syntax, now that I have made this a group in the apply and instantiate of the generics. So this I want to unwrap too. So not everything is an AST anymore, I guess, right? Can I maybe I should just have the flattening over here? That would be nice, right? Yeah, that is nice. Children, flatten children. Flatten children. So everything is an AST instead of a map like this. That makes sense. So we have this function, flatten children. So this is going to be a function which has children, which is AST child tuple, and I want to return the AST tuple, right? Yeah, that makes sense. So we now go let result be ref tuple empty, and then we'd say children iterate member child. So we're going to match child with if it is an AST, and then we're going to say result is result tuple add member member AST, right? But if it is a group, G group, then we do something else, right? Group is not a unit. This is AST child AST child AST. Is it AST.AST? It's a little weird. I mean, child in this is the AST child, and then we should just be able to do that, right? So yeah, this member let member be index name some name. don't have the built-in thing for it, do I? No. Maybe I should. Latin children. So if it's a group, group just has its own children, right? So we say group children are going to be also flattened. And then we're going to say tuple merge this tuple merge A and B. We go A and then we go B. So we do this and then we, well, first we do the current result and then we do this and then we say that we update the result. Right, there we go. That makes sense. So we don't like tuple map child expect AST. Like whenever we do this, we instead say flatten. Like everywhere. Everywhere we say flatten children. Okay, this should work. Okay, there we go. So this is Advent of Code day 1. This is Advent of Code day 2 is being tested already. Okay, so the code works. We can take a look what this was rewritten into, right? Day 1, these are the changes that we did. We just have all the parentheses everywhere for the function calls. Wait, const. Wait, what is this? Const instruction. Why is there a new line over here? That makes no sense. That makes no sense. Yeah, the first 3 days at the very least to work. Do I, yeah, let's like undo all of this and rewrite it in place again. Well, I mean, that's going to lead to the same result though, right? The const makes this on 2 separate things. Okay. Well, that's because it's rewritten, right? And this is a keyword. Wait, no, that makes no sense. Kind of. Something is... What if I just do the formatting again, though? You know, formatting in place, just without the rewriting. And then see if... So this does fix. This does fix it. But maybe something else is, like, broken still. Potentially. This over here looks wrong. List pushback. List pushback. And this is not formatted correctly. There's no... Yeah, it was on 2 separate lines. It should still be, actually. Rules. apply. I do have like the tab here, right? Oh, because I have a never here. Now I have the never, right? Yeah. And that's what I wanted to do. We want the formatter to make sure that this is not never. I mean, this group is formatted. Yeah, this group is formatted. Is formatted and not never. How do I want this to be described? So we have so this over here before the equal is the group name and the resulting struct. Then we have potentially a question mark here, which means that the group is optional. And then also we can do an I want to like specify the formatting rules for the group only, right? Well, I mean, I can say wrap like this. Wrap is the thing that is after. Well, I mean, yeah, we have like the, or maybe in the beginning of the group. How about in the beginning of the group we can have a wrap, if any. That makes sense. I also want to change the wrap to use the at. Sure, everywhere, why not? Because over here I don't want to use the wrap because that means, because it's not a keyword, so every name gets a field, so I want this to be a raw thing. Okay. Rule in the parser, wrap expected wrap. So this must be a wrap like this. Okay, so this should be wrap mode, right? If token is raw, this yeah. I want to have like a function that like that like wrap. I want to have a function, you know, like let parse wrap mode, which is going to be like lexer into the syntax rule wrap mode optional, right? So we're going to say that if lexer peak is raw wrap, then we're going to do all of this. We're going to say lexer advance. And then we're going to do this. And we're going to return some. Otherwise, we return none. And so wrap mode is going to be parse wrap mode, unwrap or else fail expected wrap mode. Sure. Expected closing at a wrap. What? Oh yeah, that's right. Because now inside of a group, over here, we potentially have the wrap mode, right? So we say let wrap mode is parse wrap mode, right? And then we just have this in the group wrap mode. So wrap mode is optional, which is like overriding the wrap mode of the parent, I guess, right? Wrap mode is should just be defined earlier. An optional wrap mode. Okay. This one I'm adding. We don't care about wrap mode here. Add into the state machine. Okay. So when do I care about it? In the formatter only. In the formatter only. Wrap mode. Print AST wrapped. We say print parts wrapped. Wrapped over here is a boolean, right? So if we are wanting to print the group over here, we have a group. Group was skipped. Yeah, I guess for optional groups. So if I have a group, then this wrap should be based on the this over here should be based on the let's say group wrapped. So group wrapped is going to be match rule group wrap mode with none, then original wrapped. Otherwise, if it is some mode, then I mean, if it is some. Wait, what? Oh, yeah. Wrapped. Wrapped is whether we should wrap, right? Or no? Where we do have a rule wrap mode. Oh, this is when I'm printing the white space. Yeah, so this is checking the wrap mode of the rule, but it should not. It should have the wrap mode. Yeah, that's what we should. We're going to match wrap mode here, not the rule wrap mode. Syntax rule wrap mode. Wrap mode. So print group also should have wrap mode. We have a group rule, so we do have the print group actually, and I don't need to do that here. forget about this. Wrapped. Wrap mode. Wrap mode. Wrap mode. Wrap mode. Okay. Value wrap mode has types in wrap mode, but expected of type group. Because print group should also have the wrap mode argument here. Value wrap has type ist group. Wrapped. Boolean. Print group. Print grouped. Wrap mode, syntax, rule, wrap mode. Oh wait, we have wrap mode here. Yeah, right. This is the wrap mode. It's wrapped, which is boolean. Okay. So the only thing is over here. So wrap mode is going to be rule wrap mode. But if when we're printing group, now we know that we have the group. So wrap mode and wrapped is going to be determined. And wrap mode is going to be determined by the group rule. So if the group rule is sum, with wrap mode being also sum, wrap mode, then we do wrapped wrap mode. Otherwise we do wrapped wrap mode. This one is using the override wrap mode. Let's call it override wrap mode. Override wrap mode. And then the fact that it's wrapped, it also needs to be group wrapped. We need to figure out if the group is wrapped. So group wrapped is group. Group wrapped is I mean, we have the AST group. Do I have the span for the AST group? Not really. We do have the part list though. So I need to have we need to figure out if we have any new lines, right? So right, let's say beginning. Let's say group begin group start is is part list had option map or. So we're going to map or position beginning part. Now I need to know the span of it. Oh my god, I need to like calculate the spans basically, right? Okay, and to calculate the spans, so part spans is parts list map part. So part is this thing. It's just like I don't have the spans for the groups. If I did have the spans for the groups though, hold on, maybe I just, you know what, how about we just have the spans in the groups. Group span is group span start line is not equal to group span finish line, right? This over here is span. It's unbound because it's not existing there. So AST group should have span. Print group. Quote AST. Quote group. Expression shape, quote AST group. This one also does not have the span. What is this? Inference completion, children, span. We ignore this one here. Interpreter core. So when I'm actually quoting the group, I say that span is equal to group span then. Okay. Parsing the rule. Group. So span is just how do I figure out what span is in the other places? Yeah, we just have parts and then we like, yeah. We're trying to collect the parts and yeah, but this over here. I want the let's have a span of, so there's going to be parsed part list and this is going to return span function parts into this. So span is span of parts. This is the span of the entire AST, but we want the spans for the groups too. This span. This span is not this span. This is the span of the group parts. Of parsed parts. Group parsed AST part. Collect children. Parsed parts. Oh wait, maybe this should give me the span. You know what? Maybe collect children. This returns collect result. Children. I like the fact that this returns a span. Actually. So over here. So over here, I just expand the span, right? So span is not this span because I need to add the span of the comment, right? Can I do span merge? Merge spans, span and comment span. Let merge spans A span B span is Yuri is A Yuri start is I mean this one is the first, this one is the last one, right? So we just say that start is A start and finish is B finish. Something simple as that should work, but then I need to give it in order. Merge spans. Oh, I mean, yeah, it is in order. Comment span and then span. Okay. Span. Span is parsed keyword. Span. Merge spans this and span. Merge spans, value, span, and span. Okay. Over here I do collect children twice because I collect the rules. So this is the span, and this is the span of the remaining things. Right? This is group bars, group children. So this is span is group span, I guess. Yeah, so I create a group. Span here is going to be equal to the group span, but the span of the entire thing is just a group, it's just merge spans of the group span and span. Can I have like, yeah, this is like parsed, span is parsed span. Parsed span, I want to rename this thing. This, parsed span. So I actually have the span over here, which means that I don't even need to collect to do this thing. So I don't need to do a span of. If I implemented that part correctly, I mean. If it's empty though. Wait, hold on. If it's empty. What is the span if it is empty? Hello? Well, I guess span is in this case must be none, you know? This span. Yeah. because the span is empty if we did not parse anything, right? So span is span option get, because I did get something there, you know. I think it means that, yeah, we're also going to say that merge spans is B is span option. So what is like the remaining thing? So we are going to say match B with none, then A, and if it's some B, then we do this. So parse span, this is an optional thing. So merge span should return a span option, but we always will return some in this case. Alright. So group span is actually the group span option get. It must be not empty, right? Okay. Next, the format CLI, rewrite group. When we have a group, it has a span. We keep the span. Rewrite group matched rule. Span. In the core syntax, this is the quoting syntax for the quoting ASTs. If I construct the group here, then we have the span being equal to group span. That is easy. Okay, is it compiling? It is compiling. Does it work? And what was I trying to do? Why did it not work even? Expression expected rep mode. Exception expected rep mode. Expected rep mode. Parse rep mode. Parse rep mode. It's not parsed properly. Oh wait, it is. It is in the. Wait, what? Rules. Oh wait. Yeah. Wait. What am I doing? This is not the thing. Rep. Let's do it with a net here. We also have the rules, which are the simple rules. Well, that's not the thing that is failing. Fine, let's see. Expected rep mode. Got this. Token print. Lexer peak. Tell me what my thing is. Wait, expected rep mode, go to rep. Over here on the oh, it's because the advent of code has the rep, has the thing. Makes sense. Let's discard the changes. Rep. Space rep. We're going to replace that with at a rep. Sure. Rep. This cannot be done like that. So now with the rewrite rules, we have something. Wait, what was I doing? Oh, we have the const, which is weird. We have two things. We have const, which is formatted weirdly, and then we also wanted to have the separate ramp modes for the groups, which is supposedly already done. If I do test, okay, if I do test KS over here, right? So if I say like a.b.c, hold on, a.b, this over here needs to be wrapped 1 and 2, and dot c like this. This does not work. Restart. Oh yeah, there we go. Now we restart, and this thing is is done like that. Makes sense. This one is wrapped separately, and this one is not, right? Yeah, that was because something was formatted differently. FD. This doesn't work. In the monad. Oh, because the monad also has the custom syntax. There is something else that is having the custom syntax, right? Over here, we have a couple examples with custom syntax. Syntax. Example and this. And custom syntax also. Okay, everything is formatted. Did it change anything in the collections? There's a huge thing. Let less greater or equal is strip split. Well, this is now yeah, I think it doesn't mean that I committed the wrong formatting previously, and now the formatting looks actually nice. Yeah, we have the wrong formatting committed. Now this looks okay. Now this looks okay. Okay. There's still this thing with the const. Can I figure that one out? Why is this not correct? Oh, because we have the begin. Yeah, I think it. Wait, what? No. Let's do another test. I want to say a const. Well, I want to say this. It's because it's only bad because it's rewriting though. Right? It's the rewriter that is doing it wrong. If I format it again after the rewriting. Okay, I should just let's just advent of code format in place. Okay, and now take a look at this. Okay. Looks better. Add a new line for no reason. That's kind of okay, maybe. Yeah, we have some like new lines which are added for no reason sometimes, right? In the rewrite specifically. I don't know how much I want my rewrite to work like very well right now. It's just like that I need to update my syntax. I think this is okay. Can I try to make sure that let's just make sure that everything works on the examples, not on the actual inputs. In the advent of code, can I do that? Can I do that? Make sure that we only test the examples. We only do part 1. No, we only do examples. Over here. Only, yeah, so this is the only day. Only day. And then we want only example. Only example is this. So if not only example, then we're going to test on the actual input txts. So let's go here. This did not work. Wait, what? Oh, only example is, yeah, only example should be this or should be false. By default, we test everything. Okay. Okay, day 1. Wait, no, there's still input txt. Oh, yes, we need to do cast this. I need to like parse my arguments here, I guess. How about I do this? This is equal to... We need to parse. For I in 0 to std sys, from 1 to sys rxc, we say that if this is, okay, let's arg v std sys arg v at I, if arg is equal to only example, then only example is true. Else only day is some or some string parse some like parse arg. This is in the prelude anyway, right? Let not only day is none, only example is false. Okay, that's better, right? Only example day 1. No, this did not work. Could not find parse in scope. Wait, is it not imported from the prelude? Maybe I'm not exporting it from prelude. Okay, so this is day 1. Only, like, let's say only day 10 on the example. Okay, day 10 actually, wait, hold on, day 10 has a different answer. I broke something. Maybe it's because I changed the syntax. Let's do only example on all of the days of the advent of code. It's also running through the JavaScript transpiler right now. Day 8 is the first day that has the incorrect thing. It's probably not the JavaScript that's not correct, but I changed the syntax maybe. Can I like do a git stash and then check? No, not here. Not here. Okay, fixed formatter. Let me just commit something finally. We did more than just fixing the formatter. Should commit more often. This thing over here, I want to stash the advent of code, git stash. Or I mean, we can just try cast test day 8. This is the old cast though, so I cannot do that. I guess we do stash here after all. But then I cannot run because it cannot parse it right now. Stash pop. Not possible. Let's push this and then like... I did change the syntax a little bit actually. Expected 40, go 12. Do I want to like figure out what's wrong in my advent of code though? And I mean, it's not necessarily means that I broke it today. I might have broken it yesterday or somewhere else. Yeah. Also, we can try running not through the JavaScript. How about this? So in the advent of code, I can say in this file, right? We are running this with JavaScript, right? How about we say with JavaScript? Like we have it as another argument, command line argument with JavaScript is true by default. And then we say that if arg is Node.js, then with JavaScript it's false. Node.js. Unless without the JavaScript my interpreter is too slow. Well, it is definitely slow even to work on the example. Maybe we can still wait for it though. It's not that slow, just like a minute. How fast does it compile? Right now I have not any problems with compilation times. But all of my programs are pretty small, right? This is just Advent of Code solutions. I don't have any incremental compilations implemented right now at all, and I don't have the problems. As soon as I have the problem, I will make sure that we have some cache of like the I don't know what to call. What should I call my compilation units? What's the line of code? This over here. I have 3,000 lines of Kast code in the Advent of Code. We can try compiling all of it, I guess. Although this also like compiles the standard library at the same time. Can you just time Kast? What do you mean by compilation though? Compiling. So like I have a two-process compilation, two-step compilation process, right? One is compiling to the intermediate representation, which can be ran through the interpreter or processed further into JavaScript, right? To JavaScript. Like just one file, just one single file, cast, compile, target, JavaScript. I mean, we can try to see how long it takes to compile the standard library, I guess. Standard library is not that small, I guess. We have no, in the standard library it's probably not 1,000 lines. It is 1,000 lines of code in the standard library, right? So the question is, how long does it take to compile it? Like a hello world, cast, compile, target, JavaScript, examples, hello world. Right? So dev null, and then we time it. Okay, 1 second. Like 1,000 lines in 1 second is fast enough for me, I think, right? If that is my speed. It means that when I have 20,000 lines of code, which is what I have right now, it is going to compile in 20 seconds. But also, I don't have any incremental stuff at all right now. Do you have hyperfine? I do. What do we do with it? How do you use it? Just hyperfine this. I do a dash dash here, or what? Command terminated with non-zero code. Is that not? No. No, this is terminating with zero code. Hyperfine command. You want me to put this in this thing, right? Okay. There we go. Yeah. Well, I mean, a second. There is no reason for it to be like much different, right? It still is the same time as I was reporting. Yeah. So this is the hello world, which is just doing the standard library. We can try compiling something else. Maybe actually hello world is for some reason compiling faster. We can try guess a number game. Is it going to be slower? Wait, it actually is slower, I guess. It's generating more JavaScript. Okay, fine. Let's compile. Advent of code 2025 day 1. The advent of code day 1 is pretty small. It is 100 lines of code. Same, compiling the same time, yeah. I don't know. What are you looking to find here? Maybe it's like the JavaScript generation that is taking the most time. Needs more Rust to be faster. Yeah. There are definitely ways to make my stuff faster. I just don't really care about it at all until I have a problem. But yeah, you can see how slow like my interpreter is, and my interpreter is being used at compile time, and to figure out. Maybe hard to fix when you have a problem. It's okay, we fix it by rewriting everything from scratch. You know? And then I'm like prototyping the language right now. I'm not even like I am figuring it out. Once I have figured it out, then we can focus on the things that I have not figured out yet, like the performance, right? Okay, but at some point I broke my language, actually. I broke the advent of code day 8 is no longer reporting correct answer. At least in the JavaScript transpiler. So I'm trying to wait here for 1 billion years already for my interpreter to actually solve the advent of code day 8. What was the advent of code day 8 even about? You mean you don't practice premature optimization? Yeah, and like there is a little bit of a problem in my game actually because of that. I mean, it's not really a problem, but if you like if you see what my game is, right? My game is written in Rust, by the way, so it's not the language that's the issue, you know. I can write the non-efficient code in Rust too. So yeah, my rendering is pretty inefficient, and yeah, I could make it like run on almost any device, but I would need to optimize. Advent of code, let's see. Advent of code was broken. Fixing. Day 8. What was day 8 about? We have something like triple numbers. Oh, this is like points in 3D, and we need to find the points which are closest together. Connect together. After making 10 shortest connections, we have certain components, connected components. We construct a graph. We have split the graph into components, and we need to multiply the sizes of the components, right? Yeah. Okay, this is painfully slow. Let's maybe cast run target JS project and the code source day 8 main. Yeah, so this is just going to run it on the example, right? Expected 40, got 12, right? So why is it 12? Maybe I can log something in the day 8. part 1. Input is red. Pair set DSU. Answer if part 1 root count we have 4, 1, and 5. Wait, what is this? 16. Wait. Can we wait? We cannot multiply. Wait, the multiplication is wrong. We need to multiply 4 by 5, which is going to be 20, and then by 2 is going to be 40, right? Why is there another 2 though? Or maybe I also dbg print something else. Did I break my multiplication? dbg print. I'm only printing the counts and then the answer in the end. Compose. Oh, wait a second. This is not correct even. I need to do this and that. Oh, I'm sorting the components and I'm multiplying the biggest 3 ones, right? Yeah. So we have component of size 4, 5, 2, and 2. But we need to take the 3 bigger ones. So we need to do 4, 5, and 2. And multiply them, we get 40. So this sorting algorithm maybe is wrong here. Fine, let's do the list. Let's do like 4x in list iterate. Or I guess... Oh wait, plus equal. Shouldn't this be multiply equal? Multiplying together. And then I'm adding them together. Hello? This was never correct. Can I see the history of this file? Guys, I don't know how to use Git, so we're going to go to the event of to the GitHub here. And we're going to check the history of the 8, because I guess I just wrote the incorrect code. That's how we broke it. This is day 2. Can I like just see the changes of the day 1? Let's figure it out actually. How to view like last diffs of last commits to a certain file. View diffs for the last end commits affecting a file. You get commit messages and diffs, oldest to newest. source day 1 main Kast. Okay. There's no plus equal. So this is the last faff commit. Did I break it in like previously? Oh wait, that's because this, right? Wait, no, it's not day. I need to do day 8. Day 8. Answer plus equal. Not found. Wait, what? Was it answer part 1? If part 1, then this. Well, why do I even care when I broke it? If I just fix it, right? Just do multiply equal here. And then it works. Input txt. Okay. Just to make sure. Okay. What about part 2? You know what? Let's just do cast test only example. All right, let's see. Let's go again. I'm going to test the advent of code fully, but only on the examples. That's probably good enough. All right, day 9, day 10. Day 10 doesn't work. Did I... Maybe it's the rewrite? Hold on a second. That's why, because I don't force. The rewrite rewrote the plus equal, the star equal into the plus equal. For some reason, could that be the case? There is a star equal here. Wait, what? So I didn't touch that code. There's no way I did it with a rewrite though, right? Or with a formatter. Okay, well, I would expect that in the day 10 there is also something similar. Plus equal was changed into the star equal was changed into the plus equal. It was. Look at this. This is my formatter. Something. How would it do that though? So it is changing the star equal into the plus equal. Or like everywhere, yes. Okay. Divide equal is also changed into this. Interesting. Why would it be doing this though? Now it's giving me the correct answer. Fine. Let's do a local test. Let's do a local test. I guess I don't no longer need to run this through the interpreter. Let's do a local test. Test Ks. Right? I want to figure out why would it do like x times equal like y, right? Is it just the formatter? It's not the formatter. It's like it must be the rewriter. Yeah, the advent of code is working on all of the examples at least. Okay, so we do cast fmt rewrite old rules is this. And I want to rewrite test ks. That's right. Yeah, look at this. Yeah, there is a plus equal now after I rewrite. What? Excuse me? There is no way. This makes no sense, right? Star equal. Oh wait. Star equal is called add a sign. Divide equal is called add a sign. That makes sense. That makes sense. But the reason it still works is because when I'm parsing, I don't care about these names in this specific case, because this is done with the syntax sugar, which is done through pattern matching. So I can pattern match the syntax independently of the name. Okay, this makes sense. What should be done though is that I should never have two things with the same name, I guess. Right? I should never have the two things with the same name. This is going to be called null assign, and this is div assign. And in the actual rules too. Let's, before doing that, go to the parser rules, syntax rule. I want to add it to the rule set. So we have duplicate rule. But duplicate rule is when the rule have the same definition. Two different rules have the same definition, which like makes no sense, right? But we want to also check if the rule, different rules with the same name basically is another thing. Right? So we have string map, updated rules. Yeah. Can I say that if rule set rules string map find opt rule name is sum, then fail on already have a rule this. Right? Or already have rule and assign. Okay. Mal assign, div assign. Okay, those are the only duplicated rules. Nice. Make sure no rules with same name. No syntax rules with same name. Okay, this is good. Advent of code. Let's do here next. Like update cast. I want to... Do I want to do anything else? I mean, I kind of did stuff today. I wanted to like maybe change more syntax of the language. I don't know if like if I want to change anything else other than the function applications. I think the only like thing that I'm considering is the dereferencing operator right now. So the dereferencing operator is the caret, because it is like it is in the middle of the keyboard and it's a little bit difficult. But you kind of constantly need it. But I don't know, like the ampersand is also there. I didn't have problem with it. Maybe I just need to get used to it. Probably is fine. Okay, what else? I was like going to figure out the macros today. Like I don't have an actual macro. We only have the syntaxes. Maybe we do something that is macros. Just it's not difficult, so it should be easy. What you cooking up? I'm making a programming language. I'm working on some syntax today, which I have not worked in a long time because it was okay, but I wanted to change it, so there we go. And right now I'm going to look into the macros. So we have extensible syntax in the language, which means that you can invent your own syntax if the standard one is not enough for you for some reason. Something like this. So you define the syntax and you back it with a macro. This quote over here is the thing that is producing the AST, and then we can like construct new ASTs using existing ones, basically, right? This is an example of a macro. But in general, the macros, they don't necessarily work on only ASTs. What I want to have is like a macro is a thing that produces the AST, but the input to the macro is not necessarily ASTs, and we can just generate any code at all. So I think in order to have this as an example, what I want is to be able to include ASTs. So we want to, you know, I want to be able to write include AST and then give it the AST. Something like, you know, print hello world. So in this case, print hello world is an AST, which we can also store in a variable like this. AST is that. And then it's going to compile this AST into code, expanding it and doing everything that is needed. I just need this built in, basically. Trying to compile error node. Oh yes, because we now need parentheses. I don't need parentheses, and over here also I need parentheses, but include AST is going to be the keyword. So we're going to add another syntax rule. We already have include for including the files, but we are going to include ASTs. Include AST. Just do underscore here. Yeah, and then we have in the core syntax. We're going to have include AST. I tried a streaming platform a while back as well. Nice. Anyone streams on your streaming platform? Or did you make Twitch or something? Include AST. Include AST. Include AST is very simple because we're just going to say that we have a single unnamed, and this is my AST, which we're going to evaluate. Compiler evaluate. I want to evaluate this thing. Type of this thing must be AST. And we are trying to evaluate AST. Right? So this is going to be value expression is this. Value is a value, expression is expression that was evaluated. So AST now as a value, when you say value, expect AST. Wait, I don't have ASTs as value yet. No, I do. No, I do. Expect AST. I just don't have this thing. Right, let's say expect AST. Like this. So we're going to match this with, if it's none, since we needed an AST, and if it is not an AST, we will need to do error. We need to do init error span kind. But if it is actually some AST, then we are going to compile this AST directly here. So we're going to say compile AST, compile find AST, right? Expected time expression, compiler data add. Yeah. So this is compiled, and we are going to return the compiled, but we're going to remember this expression for the LSP purposes. Compiled, add data, kind, compiled, expression. No, I add expression to the kind. Hold on, data add. How do I use it? Oh, it's just like, yeah, I just create this and then I add. Yeah. So we just do, yeah, we don't even store this. We just say compile this into add that. There we go. Easy. How long have I been working on this? Like over a year. Get interaction actually about 30 go live a day. I see. What do I want? I want to like have my test, right? So here's my test. Include AST. We're going to restart the language server, and this is now going to be a keyword. There we go. So this is now a keyword. This is AST. Right. Yeah. And we can do something like this. We can print hello world. So this means that this basically is generating. So I have generated code. Const means that we evaluate this at compile time. Kast examples test. And it didn't work. Nice. No implementation of string as to string. Oh, yeah. It's this code that doesn't work. There we go. Okay, so this is going to still print hello world to us, right? What? How do we do something fancy? How do we do something fancy? Like, let's say that we want to generate something based on the type, right? So I can say that let x be 1, 2, 3, and then we say that something like this. We say something like this. If type of x is equal to the int 32, then we print int. Else panic. This is actually going to panic. The reason is because this is not known to be an int 32 here at this point at compilation time until I wait, this is also not doing this. Interesting. Oh wait, I don't need parentheses here, right? On my equality, yeah, I think my equality operator just doesn't work. For this I need to implement this differently. And to implement this differently, or what I can do is I can go to my natives core mod CMP. The equality is done using the polymorphic OCaml operator, which is not exactly correct. I want instead to do, since A we do A and B on value shapes, right? So compare function. We need to have a function that operates on value shapes. So I think we have a function A and B, and we return a value shape types equal value shape. Actually, yeah. Over here we just do equal value shape, but over here we say function AB not equal value shape AB. There's probably a way. Yeah, there we go. There we go. Now this works. It's just my equal operator was not correct. And another thing, by the way, so now what we want to do is, another thing that I want to do is we want to create like the macros, the actual macros. Like, let's say that we wanted to have something like in Rust, right? You know, let's say print, let's say like dbg, the dbg macro, actually the one that the Rust has, right, is what I want. dbg, sure. So let's first let's create the syntax. Syntax invoke macro 70 wrap never is going to be so it's going to be a macro followed by exclamation mark, followed by the opening, closing, and we have AST here, right? It's not being parsed properly. Oh, so it's drop mode. Drop is like this. Yeah. Okay, and then this also needs to be a group, I guess. Let me just, so for the formatting reasons, we want to do this. Similar to the function call. Similar to the function call, we'll have a group which has the AST, which is any. Okay, and then we can basically implement syntax macro AST, right? So this can be implemented as something. So over here we just implement it as the empty thing. Okay, this does not work. Expected AST got group. Right, it's because expected AST got group. Wait, where? While compiling expression invoke macro. Here, so I have parsed this successfully. expect AST. Tuple map child expect AST. This should be Kast core syntax flatten children. Yeah, I need to flatten children there. That's all. For the custom syntax implementation. Yeah. Good. Yeah, so we have that. And we can actually invoke the macro. So macro is just a function that returns AST, right? So we need to call macro as a function, and we will need to include AST, which is the result of this macro call, right? But what is the argument to the macro? Since in this specific case, we want the argument to actually be the original AST, I guess. So we just we want to over here. So this makes the AST like that, and we want to do this. There we go. So we want to construct this value as in the AST and invoke this macro, right? Yeah. So now this is going to say that could not find macro in scope. Yes, because macro should be like this. But this is going to say that could not find dbg in scope. Oh, dbg is std-dbg, right? We need to let's call dbg print like this as a dedicated one. It's going to say that it's not found though. It's going to say that could not find dbg print in scope. So then we do that dbg print is a thing which takes AST and then it does something like dbg print what do I want? I want to like print the AST itself. And expect it in the file. Right? So if I print, you know, like hello world here, or let's actually do 2 plus 2, right? So this is just going to print me, no. This is not correct. It's because this over here, it did not get escaped, I guess. Can I do like this? This does work. Well, I mean, yes, this is the AST, so I need to like quote it here to construct the actual AST. Otherwise, it inlines it here. That makes sense. So yeah, we have the adding of 2 and 2. And then I want to say that the result of this is equal to the actual thing, right? So it's going to print me the AST, and it's going to say that it evaluated to 4. I just need a way to like print the AST in a fancier way. This is the debugging representation, I guess, of the value. So I want to print the AST as if it was just code. So we want to just see something like 2 plus 2 is equal to 4, right? Yeah, we just want 2 plus 2 is equal to 4, which actually means that that is done using the highlighter, right? That is done using the highlighter. Using the syntax highlighter. Okay. I think DBG printing the AST should be working differently. We have the print here, and we have a value AST, and value AST should not be printed like this. It should be printed as a highlighted thing. Can I add a dependency? We can have a highlight. Highlight is depending just on the default syntax. That's all. Kast highlight print. We're printing the parser result. That's all that we do. So I can also just say print AST. And we're printing to the module output. Output is a module. Initialize, finalize. Printer, which has formatter and position. So I can just use the module term so that we can highlight for the terminal, right? Is the idea. Can I say like print AST, which is going to be like FMT AST, and this is just going to be print. Let's just say that, well, I need to print it to the formatter actually. How to visualize printer? Yeah, we have printer. Like this. My output. Let module output be term. Can I do that? Output finalize printer. Print AST. We just don't do the trailing comments because we just have the AST, I guess. And then this is the thing that can be used. Kast highlight can be used as my dependency here. Kast highlight for the printing. The AST. We just say cast highlight print AST FMT AST, right? Okay. Well, I should at least say maybe like AST. AST. Oh, beautiful. There's nothing printed there. Print AST does not work because we do term, even though I gave it the FMT. No, we do have the FMT. Hold on, this is supposed to work. Initialize, finalize, print char, move to. Oh, we need like to have the proper spans or something. But I should still be seeing the things. We're printing to the formatter here, yeah. I don't know why this is not printed. Print ASD. Wait. Never mind. Guess I'm not constructing my AST properly. Maybe it's my quoting is not constructing the AST correctly. Like it doesn't have any parts, for example. How do I evaluate in the interpreter? Or like, what do I even store in my types? Expression, quote, AST. What do we have here? We have rule, root, and stuff, and then children, right? Maybe like when we evaluate this, we only print the children. And I don't create the parts, which are the keywords. Right? That's probably what's happening. Interpreter, core, quote, AST. Quote, AST. Right, yeah, parts are empty always, okay. Which means that we're not going to be able to print it there. Okay, well, I mean, I can fix that later, I guess. Fine, AST print. AST is all that we do here. And this is going to be a to-do. Two and two evaluated as 4. So I want to move this to the standard library. Yeah, so like macro invocation is the same priority as the as the function calls, and I guess they are also left associative similarly to that. Yeah. Good enough for now. I think I want to go rest now. Let's just say that this is a simple macro example, not a test. I want to have macros KS. And maybe we will do more examples that make more sense, maybe. We want to have some alternative to the derive macro, right? Where we derive a trait for a type. So we just give it the type, and then the compiler should give you the information about the type so that you can create some code which represents the implementation. Sure. All right. Progress has been made. Well, let's stop making progress now.
For type slots.
Okay, see you guys later. Thank you for watching. Bye.
A function's return type. Is there any other place where we would use this other than here? That's a real question there.